Thank you, sir. Thank you for the introduction. Essence. And good morning, everyone. Uh, Talk on constructing one factor effect while keeping other factor concept, but we can't examine the interaction effect. So then we will go for factorial design, which can estimate both factors and the main effects and the interaction effect together. But using this design, we can't estimate the optimum conditions for any process or product optimization. And the design is not assured of properties that respected to deriving the optimum. So we will go for, in this case we will go for the application of response surface methodology, which is consisting of we will setting we will formulate the experiments using required input variables and the target response of interest, and we will model the data which is using the best fit model, which is a best fit. And after deciding the model which is best fit, we will go for determining the optimum input factor levels uh, that give the desired response. It may be a maximum, minimum, or our targeted response. So in a response surface methodology, we will use the response surface design to explore the relationship between the explanatory variable and the response variable. So for the applications of this methodology, for example, in agriculture experiment, if you want to find the optimum factor level setting of fertilizer that give the optimum grain yield. In case of food science, there are many process optimization such as roasting, extraction, drying, extrusion. There are several process conditions in which we will use the response surface methodology to find the optimum input factor combination that give the our targeted response. Likewise, in fisheries, we will optimize, we will find the optimum conditions of factors in cultural, in studies of cultural condition, inside the system of this we can relate the relationship between response and input. So, we want to find, we want to make the functions approximate using Schur degree. So the polynomial which activate as relationship because uh, small design. So when we increases the number of input factors, automatically there will be a tedious in estimation process. So to formulate the design, you want to choose the experimental run, or we can say design points, such that it can estimate the all coefficients independently, and the variance of all the response at each point from the distance should be same. That is the rotatability condition. This is the two property that we will consider while constructing the response surface design. So this is the statistical model behind, that is a first order, second order, and third order model. And if we give the notation in matrix, we can give the notation like this. So by using OLS estimate, we can estimate the parameters beta and the variance and the prediction variance. So the notation, if we take two factors, then first order model will consist of the intercept for one, and the matrix consists of the main effects, that is linear term, and the x dash x matrix will be of this form. When we go for second order model for two factors, we will have the linear term and quadratic term and the interactions, and the respective matrix will be of this form. X dash x matrix will be of this form. When we go for third order response surface model, the matrix will be having the linear, quadratic, interaction, and third order terms. So these are the matrix. So the final concept is we want to uh, combine, we want to choose the design point such that it should satisfy the condition. So if you choose the design point, if satisfies the condition 1, 2, 3, then that design points will be called as first order response surface design, or we can say first order rotatable design. And the condition which satisfies from 1 to 5, then the design points will be a second order response surface design or second order rotatable design. Likewise, from 1 to 7, it is called third order response surface design. So there are various response surface design. If we construct the response surface design that each factors having same level, then it is called symmetric response surface design. Or when we have the mixed factor level, then we will call it as asymmetric response surface design. And another approach, that means sequential and non-sequential. In sequential experimentation, initially we will experiment some design points that fits the second order response surface model. Then if it is a comes to be good fit, we will stop the experiment and we will go for finding the optimum using optimization. Or another one approach is when the first design, first experimental setup comes to be a model comes to be inadequate fit, then we will experiment some more additional run such that together will fit the higher order model. So the major difference between sequential means we will execute the experimental trial in stages, whereas in non-sequential, if once model comes to be inadequate, we won't use the design points. Then again we will go for fresh design points. So compared to these two, sequential that is cost effective. So the overall the procedure of that technique is, first we will select the input factors that what are the required factors we need in your design using the screening experiment. Then after selecting the input factors, we will experiment using the second order response surface design. So there are several second order response surface design like box Benkin design, central composite design, or likewise. And using that design points, we will get some response. Then response will be fitted. If that be adequate, then you can automatically go for optimization procedure by using different optimization technique. Procedure for sequential response surface design. So why we need for this sequential third order response to be a inadequate fit? So in such a case, you want to proceed by experimenting some additional run to explore the higher order model. So in this case, we will have the application of third order response surface design. How we will construct this design means, first we will construct the second order response surface design that satisfies the condition of 1 to 5. Then we will add some additional run. That run should have the different radii, and our overall total run will satisfy the third order rotatability conditions. So overall, the point which we are selecting should satisfy this orthogonal rotatability condition as I mentioned before. So where the application of this design involves means, for example, in fishery experiment, we want to find the optimum conditions of enzyme hydrolysis process, where the input factors are pH, temperature, and enzyme substrate ratio. Here objective is we want to maximize the degree of hydrolysis. So in first stage, we are going to that we can go for using the second order design points and respective observation. Here in first stage, we are experimenting this 16 runs or trials, we can say, where first factor pH will have 3 level. This number in this -1 +1 0 indicates the level mentioned in coded form. We can convert that, will be converted into original unit as well. Here for uh, to know, I just given n in coded level. So my +1 -1 0 represents the low level of pH which I have taken, and -1, +1 represents high level, 0 is the your middle level of the pH which we have taken in our study. So all three factors will have, we have taken three levels, and the response we have observed, that is the degree of hydrolysis using the second order design, that is box Benkin design. So now we are having the response. Now we are going to fit the model. If now when we fit the second order response surface model, we from ANOVA we can see that here lack of it comes to be significant. As I said, if the model comes lack of it comes to be significant, then it indicates the model is inadequate for the data we are fitted, data we are having. So you want to explore the other parameters, higher parameters. So now with by keeping this first stage experiment and the data response as such, we are continuing the experiment by experimenting some additional run. For example, here factorial point runs and the response, and some axial points we have run. Then we got the response. Now we will fit the overall with 1 to 30 response. We are going to fit the third order model. So after fitting the third order model, your R square is increased as well. When come before it is 0.8, here 0.9, and the BIC AAC value is minimum when compared to previous. And also the lack of fit of the model of third order now comes to be a non-significant, indicates the adequate model. Then we can proceed now with this applying the optimization technique to find the optimum input factor level. So these are the some few designs of sequential third order. And when we are having the input factors at the symmetric level, we can go for this sequential order response surface design. But in some case we need the factors, that means we are having the factors each at different level, that is we call say mixed factor level. In this case we want to use for sequential asymmetric third order response surface design. That such design can be constructed by using the transformation matrix. So here we can take X is some design points. Initially we are asymmetric response surface design, and after making the asymmetric response surface asymmetric level of second order response surface design, we will add some design points such that transformed again using orthogonal transformation. And if you merge these two design, we will get the overall a 5. So two factors having 9 level, another one is 5. This is asymmetric response surface design. Another one, second set of stage will have different levels, 7 7 and 3. And this is one part. Another one, in terms of cost effective, in some experiment we can't change the level often. For example, if you want in first experimental setup, the level of the temperature we are keeping as higher, 100 degree Celsius or Fahrenheit, whatever. Then suddenly in second trial we want the 30 degree. So sudden changing of the factor level in some experiment will be tedious, or will be time taking. So in such a case, if we go for designs or that factors having minimum level change, then it will be cost effective when compared to your standard ordered design. For example, if you take the 2 power 3 factorial run, here the number of our first factor, the number of changes will be 1. That is from -1 to +1 change will be there happening one time we want to change the level. Whereas in B, we want to change the 3 times. Whereas in another factor, we will change the 7. This is your standard order. But when we apply the process, that is minimally change, we made to maintain the minimal level change. If we maintain, we will get the number of changes is 2 for second factor B and 4 for third factor. So when compared to standard run design points, we'll have minimum number of level changes. So here in this, if we use this first experimental setup, we want to change total number of changes in level in experiment will be 11, whereas in if we follow the minimum level change design points, we will have the minimum changes, that is 7. So for example, how to construct that minimum level change design. So initially we want to take the, if you are having two level for one factor, one input variable, that is -1 +1, low level and high level, and we want to repeat that again once again in order to get the total number. So for 2 power 2 fact, this is for 2 power 2. For 2 power 2, we will total number of run will be 4. So we will repeat individual points again, -1 once again, +1 to get the total number run 4. Then, and for second row we will take the -1 +1 as such, and we will take the fold over, that is this will be taken as folding of this place. So at last we will get the minimum level change factorial points. This is for 2 power 2. If we continue, we will get for 2 power 3. For v, in this procedure can be continued for v number of factors. And sequential third order response surface design, we usually with minimum level change, can be constructed by merging any of these following sets of combinations. So there are 6 sets. If you merge uh, this using these sets, we will get the sequential third order response surface design with minimum level changes. For example, set 1, from set 1, this is we can say it is a it is like the factorial point combination. So if we are taking the factorial point combination, that there we are taking two factorial point combination with having different parameter value a1 a2. So if we are maintaining different level, we will have two factorial design points merging. So first set will have minimum level changes which we obtained as said previously. Another set with different value of minimum level changes. If we merge, we will get the factorial points having minimum level changes which will be used in third order response surface design. If you have same level, that means both a1 a2 we are fixing as same value, then we want to repeat each runs once again to get the total runs. For example, another set points which is we can say it is of axial point. So how to construct the axial points having minimum level change? So first we want to take the two level minus c and plus c if we take, and if you want to maintain this level in diagonal form, up to you how many factors you are having. Now I am here having 3 factors, so I am keeping the two levels in diagonal forms, others will be maintained as 0. That is 0 represents the middle level of the factors you have taken. So likewise, uh, we can use this axial point. From the axial point, how we are converted into axial point having minimum level changes. Here this number represents how many changes we are doing when skipping from one level to another level in the experiment. Another set, this you can extend this axial point by taking two types merging. So first 6 points is as such we have seen previously. If we are merging another set of axial point having different values in reverse order, we want to merge it. So if you merge like this, we will get the utmost minimum, that means your minimum factor level changes. So this is set 5. We will get likewise set 5 using the BBID incidence matrix. We will formulate the design points. So we will take the incidence matrix. We will place the 2 power 2 design factorial points inside the incidence matrix, multiply with incidence matrix. At last we will get the BBI box Benkin design points with having minimum level changes. So at final we can see through this method we have constructed the two design. One is called minimally changed augmented box mounting design. That is first design, first stage, that is first set of points consist of minimally changed set we have used, and second stage consists of minimally changed sequence of axis point. So this is we have made the catalog for 7 factors that is having this is the number of runs for each factors. And through this method we have found that the minimum total number of changes for such design is 3362. Likewise, in parentheses it represents individual factor wise level change. For example, for we have illustrated one design for 3 factors. If you are having 3 input factors, this first 1 to 16 points will be called as Box-Behnken design, which having minimum level change in the factor level. And in second stage, you can, if this from this first block design points, if model found to be adequate, can stop this in this stage, or else we can continue this one by taking the second stage design points. Another one design we have constructed is minimally changed augmented fractional Box-Behnken design. By merging the minimally changed run sequence of central composite design and minimally changed run sequence of fractional Box-Behnken design. Example, for 3 factor, we will have minimum run, total run is 24, while 9 runs will be used to fit the second order response surface design, and another 10 to 24 run will be used for fitting the third order response surface design. This is general expression, and this is the catalog for the design developed. So overall, the response surface design will be used for any process and product optimization. In that sequential third order response surface design will be useful to estimate the third order parameter when the second order model found to be inadequate fit. And the minimum level change response surface design will be used when we are having very hard to change factors in our study. See, these are the some of the references, and to these are the some of the R few two R packages we have developed how for the user point of view to construct the or to have the design experimental run of third order response surface design. This is a R package Toad, and another one R package to get the asymmetric second order rotatable design is asymmetric SOAR. And SAS macros also available for generation of response surface design. If you interested in response surface design to have the overall development happen so far in response surface design, we will you can go through the review article published in Communication in Statistics, the theoretical development, which will have the development taken from 1951 to 2022, past 25 years, 75 years. Sorry. And for a brief uh, idea on the sequential asymmetric design, here we have the paper publication, and for a minimum level change run order consideration while making the design. Thank you, sir. Thank you, sir.
Thank you. I hope my slides are visible. So at the outset, let me thank the organizers for inviting me for um, this conference to talk on data science and agriculture. I also would like to place high compliments and regards to the efforts of the alumni of Department of Statistics, Andhra University, by bringing a galaxy of statisticians and having this conference so that the new generation of the students and others will understand the legacy of Department of Statistics. Particularly, I'd like to compliment Professor Tirupati Rao, who has taken all pains and all others. So with this, let me go to my talk. I'm going to talk on a very general, and my talk will be going to be very general. And I'm not going into details of many of the things, but I will point out the issues. My purpose of this talk is to make the statisticians who are here, students who are here, to understand the issues wherein the data science or business and analytics can be used to solve the problems of agriculture. So I'll be talking very briefly about data science. I'm not going into all aspects, but I will be pointing out the key issues where which is there in agriculture, and I will also showcase you some of the use cases where the data science has been used in to solve certain issues in agriculture. And there are, again, in these cases, there are several open problems are there which requires a fresh look, fresh approach, without any kind of biased or with a backlog. So the last part will be the one wherein I'm closely associated. That is how to use data science in plant breeding. So this is my outline. See, every 10 years or so, every decade, you hear some buzzwords. The buzzwords keep changing. People talk about various things. We have seen the changes in the 90s and early 2000s, and present there are these kind of buzzwords usually comes. One of the tool people used to talk about, for example, early application of computers, people used to talk about MIS reports, which is supposed to be the kind of data-driven decisions. I mean, you create a report and people will use that report to take decisions. And then it slowly moved into, people used to talk about business intelligence at the end of the century, where people used to think about that, okay, it is not should be able to visualize it. We should be able to go for some kind of drill down and all. And many times people would like to know, define some what is called as KPI, key performance indicator, and then try to see what is going on. But around after the turn of the century, around 2000, there are companies which emerged, which seems to behave differently as compared to the traditional companies. And these companies were called something like Amazon, Facebook, and all, where every decisions, it seems to be based on data. And then around that time only, people were started talking about a new science, data science, which deals with extracting knowledge from large volume of data. But this is what we have been doing from when you take R.F. Fisher or anybody. We were all talking about this one. Only difference is now what we have is a huge amount of data, and we have new computational models are there, and the computational powers is also increased. So this again another term which came but everything got picked up around 2012 when this article came in, when Thomas Davenport, who along with Professor DJ Patil, when they wrote this article, data scientists and mainstream media picked up, and everybody started talking about a data scientist, and everybody is after this particular science. So, but who is exactly a data scientist? A person who is supposed to have this the usual soft skills, something like domain or soft communication skill and report writing. But more importantly, that data scientist, modern data scientist, should have a full comprehension about the mathematics and statistics, and also computers, programming and computers. But it is actually the term afterwards, people started looking for whether anybody has thought about this, or it is just after this article, people started talking about it. In fact, this entire thing was envisaged by Professor Jeff Wu. I don't know how many of you are knowing it, particularly students, but Jeff Wu is a very a prominent statistician who has contributed a lot in design of experiments and sample surveys, as well as is the one who proved this EM algorithm converges. He, in his inaugural lecture, when he was appointed as a professor at University of Michigan, he talked about we need to have a new name for statistics, and the one which he thought that should we call it as a data science. Because and also he wanted to make a bold proposal way back in '97 that statistics should be called as data science, and statistician should be called as a data scientist. So what he was telling about is that statisticians try to try to develop some models or something, and then they stop there. They don't go beyond that, in the sense that they don't want to tell others that what results are talking about. So which he called as a statistical triology, that is what is called as collection, analysis, and interpretation. So he told us that as a statisticians, we are good in two things. That is, we know how to collect data, we know how to analyze the data, but when it comes to interpretation, because statistics is being applied in various domains, and most of the time statistician may not have the domain knowledge, and then so they stop trying to interpret the data. So that is where that was the behind this. So that is what now everybody is also talking about, that you can't just be a statistician, but you should also have, I mean, domain knowledge. Maybe it could be economics, it could be sociology, it could be medical, or it could be biology, or any other subject where you want to apply statistics. So let me, so this was the, now everybody talks about, even programs are there, even CBSE is having a, even in class 10 and class 12, they have a subject called data science. So this is how the subject has gone in. So everybody talks about it, and everybody also talks about this so-called big data. So I think many of you might have heard about it, that volume, variety, veracity, and then people go on adding these V's to these. But the big one, what has changed is that if you still have a structured data, and even if you have a volume of data, so long as it is structured, things becomes simple. Only you need a new computing model. Maybe you can go for a grid approach, and then you can solve the problem. But when you have a unstructured, or when you have a natural language processing, then it becomes a kind of different ball game when you start thinking about applying things. So this various types of data, and there are tools now available to handle all kinds of data. So some are computationally feasible, some you need to work on, and maybe you need to process it before you start applying these. So this is what some of the issues are, some of the types of data people work on it. Once you understand what kind of data you are working on, then you can start up this. And now I don't want to go into this. Even though we learn all these things in a different name, but when it comes to machine learning, people use different jargons. So like regression, classification, these are all called supervised machine learning, and unsupervised machine learning will be something like cluster or association rules. So this, with this background, let me move on to two things. The first one is, do we really have big data in agriculture, at least in agricultural research? Let me tell you that what we have at present is experimental data. Most of the in research setup, what we have is typical agriculture data. Research comes from the experimental data. Of course, there are a few exceptions are there, but the experimental data, they are all very small. And then these crop improvement trials, what we call it as our India crop research projects, wherein the new lines or new varieties are developed. These trials, again, they are not too big. They are maybe the volume is slightly more, but still they're not very big in terms of what we call it as big data. The one more biggest data what we have in agriculture is this, what is called as a georeference, where georeference data indicate or talks about that maybe weather or soil or other things, wherein we are referring to a large geographical regions. So this, it may be considered to be big, but still it can be handled the usual means. And remote sensing data, again, of course, it could be very big, even if you take about a very small area, maybe a district or a state, and if you go for high resolution remote sensing data, then it could be really big. But people process it depending on what is there. This one, there are, for example, in IRA, we have something called monitoring the crop residue burning. So every day, satellite data is collected, processed, and then a map indicating the sites, say in Punjab or Haryana and Uttar Pradesh, Western Uttar Pradesh, where the in the month of November, November or late October, November, heard about the pollution at Delhi is because of the crop residue burning. So the maps are produced every day so that one can monitor it. So this is processing a satellite data collected by remote sensing satellites, process it and identify the locations where these crop burning have been observed in the previous day. So this is something like, but it can be a big, but it can still be processed by the usual means. It is automated, fairly automated. So it comes, everyday map comes, and including number of places where the burnings, a number of burnings in each district or each state has been reported. Farm services and advisory, some companies are working on it. We will come to this a little later. But from where we are going to get a big data using which is a kind of prerequisite if you want to apply these machine learning and other data science tools, because if you don't have a sufficient data, then these are not going to work. So I will try to put it in at different levels. At various things, and like farming, post-harvest, marketing and processing, and agriculture finance, insurance, certification, traceability, and policy level. So in each of these, we can have, we can apply data science, we can look at the issues, what which can be collected at these individual one. Now, with respect to farming, as you know that our country, where the number of farmers, many of the farms are small and marginal, and if you want to provide a kind of advisories, say for example planning, or how do you go about maybe how to optimize the land resources, something like what to grow depending on the resources available. These are all, if you take at, it is all individual advisories. And again, the second level of farm level will come, advisories will come how to efficiently use input, like when or where and how much and what. So this is again, if you look at the size of the farms which are available, these are again, it is open, how you can collect the data, how you can build a model and provide advisories to individual.
அப்படியே போடாதன்றேன். இன்னைக்கு ஒண்ணு போட்டு வை, ஒண்ணு மட்டும் போட்டு வை, அப்பதான் தெரியும் குடிக்கிறாரே எந்த நேரத்துல
Actually,
குடிக்கிறாரு.
can somebody mute?
நீ மொத்தமா 5 போடாதன்றேன். அவர் அதனாலதான் குடிக்க அவனை ஞாபகம் வச்சிட்டு இருப்பாரா? அவருக்கும் திருப்பணும்
Can
அவரு
somebody
காலையில
mute?
கொஞ்ச நேரம் கழிச்சு
Oh, hello. Can you mute, please? There is, yeah, okay. Thank you. Yeah, thank you. So this farm level advisories, a huge opportunity is there in using which, data science tools can be used, and different kinds of data science tools are required. For example, planning or efficient input use. You may have to build a model, say plant protection, maybe surveillance or prediction, which requires image-based classification and other things, and harvesting most likely using a machine to pick up the to take a decision whether to harvest or not. So it is expected that individual farms, particularly using these sensors, that the data points generated per day is going to be something like 4 million by in another decade or so, 3 to 4 million points. So this data points going to give a lot of ideas, these issues which can be efficiently handled by so that the decisions can be made using the data collected at the farm level and aggregate it and provide an individual personalized advisories. At present, the advisories are mostly very generic, may not be, and to those who are grown a particular crop, everyone, a very generic advice is going, but if one can work on a personalized advisory services, there are companies like TCS and all. Most of them have this kind of a conceptual model wherein they think about that we can go for a kind of holistic farm advisory services. So these are all, again, you need to have all kinds of data science tools, maybe image classification, then you would like to take a decision, and then where to get inputs, what inputs, and what kind of schemes, credit or government schemes are there, or how many laborers is required, how he is going to hire the farm machineries, and plant protection and weather advisories, and then finally selling. Now, if you look at these, I have not provided all the exhaustive decisions what he is going to take, but more or less all these things are going to cover. Wherever these bold decisions are there, wherever I put the bold bullets, these can change, these can change a little bit, change from season to season. But all other things, they are all one-time information. And many times, what is going to happen is this farm advisories. There is not much value is going to be there. So that is the one biggest challenge, that farmers are not going to give you. Farmers are not going to feel that you are giving some value to that. So unless and until these whatever your advisories are there, they are given at a very low cost, nobody is going to take. So unless the value you are creating, these advisories will not be saleable to farmers. Coming to harvest, there are a lot of advancements are there. There are now harvesters for various crops which uses some kind of data-based decisions or AI-based decisions. Particularly, for example, tomato, when tomato harvesters or tomato pickers, which can pick only the ripe tomatoes based on a classical problem in AI, that you see the image, gather the image, and then process it, whether it is a ripe one or not based on the color and the kind of color intensity you are getting, and then pick it. And this decision has to go that you implement those model in the machine, and then that once the decision of the model is conveyed, the machine should be automatically pick those things. So these kind of tools are still available. There are also harvesters which can usual mechanical harvester, where people have put some kind of a lot of open challenges are there. How do you do replicate, or how do you do this for various other crops? So this is still an evolving area. But one very easy, what I can't say easy, but one problem one can attempt. So even though there are a lot of attempts are there, is to assess the quality of the produce. If you see that today, what happens is that when the farmer is going for selling his produce, they have to sell it at a dedicated APMC mandis, Agriculture Produce Marketing Committee. These are what is called as APMC market yards. So these producers are auctioned. So usually only limited traders participate. So they kind of becoming a cartel, and they try to get the produce at as low as possible. But the price depends on quality. So more traders from other regions cannot participate unless their representative or their agents are present, because you need to understand the quality, and you can't if you can't assess the quality, then it is going to be difficult. Of course, one can have the quality certified, but quality certification takes a lot of time. At the present way of selling goods, this quality cannot be assessed within 1 hour or so. So wherein this is an exact problem where one can use the data science. So there are few startups kind of models, and they are working on improving them, but still there are a lot of open challenges which are there, like can you use some kind of image analysis based on the produce which are there? Can you do it? Can you assess it and give some kind of quality grading for this produce, whether it is in the open lots or it is in the rack, without opening or without doing any kind of things? And problem that you are going to have a continuous data, because every day it is going to come. You can go on validating your model, how quick it is, how good it is, and you can apply these machine learning techniques, and everybody wants the quick time results. So this is again a challenge which is still there, that how do you assess the quality? If this is resolved, then any trader can, and if the models are reliable, anybody can participate from anywhere in the country, and then participate in buying of this produce sitting at one place. They don't have to send somebody to buy this. So that is something. It's an insurance. I will take another maybe about 5 to 7 minutes to complete my talk. I hope I'm not delayed. So this is typical to any banking or anything you want to target or compensate claims and fraud detection. So finally, two major areas still where we still have issues I'm still trying to point out. See, the area and yield estimation is one of the earliest application of statistics, and particularly sample surveys in our country, where yield is estimated using what is called as general crop cutting experiments. So this general crop cutting experiments is proving to be very costly, and the methodology was developed to give a good estimate at district level or at the state level, state and national level, but not even at district level, but mostly at state and country level. So there is one center like Professor Malanovi's Crop Forecasting Center, and other even Ministry of Agriculture, Department of Agricultural Cooperation is trying to use the technology-based area yield estimation as an alternative. They are using it, but as not as a replacement, but as a complement to usual general crop cutting experiment. So the approach is you have high resolution remote sensing images. It may be suitable for a large area, maybe at state or country level, and then try to use it. But this approach again is fine at the replacing at crop cutting experiment, or reduce the number of crop cutting experiments so that we can save crop, but at the same time you get a more valid estimates. Again, the biggest challenge is that yield estimates, particularly at a lower level, even at farm level, because when you want to provide the compensation under the Fasal Bima Yojana or crop insurance, you need the yield of the is much smaller area, maybe village or even at the individual farm, so that the compensation can be based on the loss in the reduction in the yield. So this people are trying with drones, but again, drones are costly to operate. So how do you optimize it, or how do you estimate the yield? Area can be estimated using drone with not much of problem, but yield estimation using drone images is still a challenge. Earlier, we used to have what is called as a high estimation in agriculture statistics, that the mandal, the patwaris are supposed to go and get a high estimation of crop coverage after first sowing or something like that. Today, that is all replaced by a remote sensing how much area is covered and arise at say June to August 31st. This is a map how much area is covered under rice. So that is estimated, and one can see that in which areas the rice has been taken up, so that you can monitor whether the rice area is reduced or increased, or how do you expect the yield is going to be. So this is something which people are using. And of course, the crop planning is one area wherein a lot of effort is still required, because as you have seen that in the last year, this current year itself, the prices of tomato is so volatile that somewhere in May it was something like 160 to 100. And today, I think in the last November, it is something like 2 rupees per kg. So how do you give a proper advice that whether what will be the expected price so that the farmers can take a decision. So now let me come to the last part of my the talk, that is how data science is going to meet plant breeding, how people are more excited about applying the data science tools in plant breeding. See, in plant breeding, there are several stages, and plant breeding is something like you need you constantly you create newer varieties or hybrids so that the yield will be going on increasing. So even though your area under the crop may decrease, because of the increase in yield, you should be in a position to cater to the needs of the growing population. So there are stages that a breeder may start with lines, and that is called parental selection. The breeder may select different kinds of parents and go for some kind of crossing, and then try to select those parents which are showing some kind of. So this is usually called a general combining ability. It is something like an average. And then going for what is called as a line development. Maybe they will be taking it in a small plots. These crosses are now evaluated for some kind of what we call it as specific combining ability, or something, what is something like a variability or variance. So this, the number of data points will go on increasing, say from maybe 1,000 points, 1,000 to 10,000 plus point when they come to line development. And the third one is that based on these lines, the stable ones, because some may, even though after crossing, some may show, may not be say, it may not be proper. So maybe some kind of, again, you will have to go for more testing so that you have a stable line. So maybe in this, till the first two, you may have a very few, may not have replication. So here you may have some kind of replication, how the progenies are performing, and then you go for a large scale evaluation and then frontline demonstration. Now, what is happening is that this entire process may take, depending on the crop, maybe 6 to 8 years. So 6 to 8 years, maybe after 6 years, you may be able to, you may start with 1,000 crosses, but at the end, you may be able to release 1 or 2 after 6 to 8 years, out of which one maybe in every 2-3 years, you may get one line which may maybe prove to be highly successful. So it is a lot of effort goes on, a lot of people work on it, and ultimately the kind of things decisions we are going to take still require a lot of improvement can be done, because several places the breeders use the visual appearance, particularly in the early stage of selection. So there are various tools which can be used, something like one can use regression in the parental line. Line development, it is you have to classify it, promote or not promote, or carry out for the varietal. And commercial evaluation is usually the kind of business of experiments, ANOVA models are used. Then this entire thing, if you look at a data science point of view, that what we have is, say, something like a optimization process, and that optimization process is a multi-objective one, because we need to maximize on several characters in different environments. But there are several constraints which are there, mostly the cost, economics, physical limits, that is you need a piece of land and experts and other things, and also the generation time. So how do, at present, what is being done is that all these things are optimized typically through a sequential prioritization. That is, you target certain desired traits, something like disease resistance in the early stage, and then hoping that you can optimize the yield at the later stages. Now, the breeders usually pick up the parents based on certain characteristics or whatever is notified. But how do we use something like if you can have a genetic genomic information? How do we use this? So people are thinking about that before parental selection. This should be, maybe we need to have some kind of model wherein one can reduce or one can set screening the process which needs to be done through a model using genetic information, and then are the performance of the parents in which have been used earlier. So if you can have such kind of model, then in the first stage and second stage, at least in the first stage, the crosses are determined by the model. Even if the model is about 30 or 40% accurate, then your chance of getting a good line is going to be there. But the challenges are many because what we get is the performance of any new line may differ differently locations. So this is one kind of example I'm showing you, that this is how we try to see that whether is same these lines, that is a basic biplot. The lines are the locations at which these the numbers which are all genotypes which have been new lines which have been tested. You can see that the performance of many of these lines they are going to different. The one, say for example, what is there in Karimnagar, the entries which may perform very well in Karimnagar may not perform very well in Sabor or Nadia or Bharuch. So it is going to differ. How it is going to differ, it may vary from trial to trial. And these trials usually conducted across years by multiple persons. But the problem is that the quality may not be, the quality of the data may not be highly reliable. So we need to see that whether these data, because the model which I was talking to you is going to depend upon how good is your the previous data points are. So these ACRIP trials are the varietal improvement trials because so many people are involved, and it is a field experiment, so a lot of experimental error will be there. So I try to analyze a few of the trials, maybe about, I think about something on an average of 11 locations, so 67 into 11 into 5 traits. Each this is for one trait. You can see that even if you take a very moderately view about what you mean by low quality, about 30% trials are rejected. That is only about 70% trials are good. So you can see this is for one trait. You get similar results are there for other traits. So this is the reason is that sometimes what is going to happen is that the initial stages, say for example, this is a single trial for 3 replications. You can see that clearly this biplot shows that there is something which is in this analysis. So that is what we are trying to do. And see, when this is what is called as a pooled analysis. And the pooled analysis, we based on the which locations we can keep, and then try to see that how the entries perform at different locations and where we have not tested it, so that the use of the data from the varietal improvement trials can be further enhanced. But this is still work in progress, but we hope that we should be in a position to come up with some kind of models wherein we are able to showcase that any location, even if the trials are not being not available, or not what we think or what we are looking for, is that we can achieve, we will be under overachieving. So this is something we are trying to overcome. That the data availability is going to be limited, at least in many areas in agriculture. But at least we can use this limited data in an extensive way, so that we will be able to remove this bottleneck in agriculture by using many of these. So let me stop here. And once again, let me thank the organizers for providing me a platform to put forth my views and other things. So thank you very much. And yeah. Thank you.
Yes, sir.
Yes, sir.
Audible, sir.
getting ready?
Yes, sir.
Yes, sir.
So shall I share my slide? Yes, sir. Due to sir network connectivity, it's little bit late, sir. It's connecting. Sir, it is visible, sir. Okay, sir. Yeah, I get. Okay, sir. Yes, sir. Okay, sir. sir, due to some problems. Sir, can I present my presentation after? Oh, okay, okay, sir. Sir. So, good morning, my respected dignitaries. I, Moushumi Rai, Research Scholar of Statistics, Assam University. I am going to present on the topic of a compound of gamma and Shankar distributions with applications. Sir, 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 now I can share my screen, sir. Actually, it's open. Okay, sir. Now it's visible, sir. Okay. So my topic is a compound of gamma and compounding a compound of gamma and Shankar distribution with properties and applications. Firstly, introduction. Sir, is this visible now? Yeah. Okay, sir. So, sir, introduction part. Yes, sir. So, to describe modeling of data in different disciplines such as engineering, agriculture, then we use statistical distributions are applied. So, due to the usefulness of statistical distribution, their theory is widely studied. Distribution is because the generalized form in most cases provides larger efficiency and flexibility in modeling real life data. So here I am at some literature review. Actually, so there are four important continuous distribution for modeling lifetime data, including one parameter exponential and linearly, and two parameter gamma and Webber distributions. So my motive to introduce the new distribution is that in 2015, Shankar proposed a new distribution called Shankar distribution, which is a mixture of exponential and gamma distributions with mixing proportion theta square divided by theta square plus 1. And after that, in 2019, with others proposed a new distribution called gamma and linear distributions. And after that, in 2022, Thara B proposed a new compact exponential linear distribution. So in this paper, a lifetime distribution named gamma and Shankar distribution has been introduced by compounding gamma and Shankar distribution. So here is the PDF and CDF of gamma Shankar distribution. Here is the graphs. So PDF and CDF graphs for alpha less than 0.5, it's decreasing, and greater than 0.5, then it's unimodal shapes. And here is the reliability function and hazard rate and reverse hazard rate function. And here is the graphs of hazard rate and reverse hazard rate function. So here is the quantiles and moments. We find here the quantiles and moments for RF. Here moment undefined. So the R negative moments we found equal to 1. It's here the for R equal to 1 we get the first R negative moments, and R equal to 2 for second negative R moments. For R lambda less than equal to 1, the negative moments are undefined, because here is the alpha -1. So if we get 1, then it's undefined. So here is the stochastic orders. So we find here the theorems for x follows to Gamma-Shankar distribution and x to Gamma-Shankar distributions for alpha 2 and beta 2 here the parameters. Then if we alpha 1 equal to alpha 2 equal to alpha, we put, and beta 1 less equal to beta 2. Then if we equal to beta greater than 1 with alpha 1 less than equal to alpha 2, then we get x1 less than I likelihood x2. This which implies the x1 x2 stochastic order. So here is the maximum likelihood estimation. We find it the log likelihood function, and here is the strength reliability. Also I found here's the application. Here's the two data set. First one, the 46 failures of airborne communication receiver, and next one is the waiting times between 65 consecutive eruptions. So I found the table 1. I calculate the -2 log L AIC and BIC of the distribution for first data set. Here first is Gamma-Shankar distribution. So if I here the Gamma-Shankar AIC is less than the other corresponding distributions such as gamma Linley, quasi Linley, a 2-parameter Linley 2 and a 2-parameter Linley 1, and variable gamma Shankar Linley and exponential. And next for next data sets, yes sir. Sir? Yes, sir. Yes, sir. Yes, sir. So I found that the Gamma Shankar distributions gives much closer fit in several data sets. Here I only use 2 data sets. So after the conclusion, we find that the Gamma Shankar distributions gives much closer fit in compared to other other distributions. Which I mentioned here the table gamma Linley, quasi Linley, 2-parameter Linley, a 2-parameter Linley to variable gamma Shankar Linley and exponential. So here is the my references, and thank you, sir. Okay.
Yes, yes, sir. I'm ready. Yes, sir.
Yes, sir. The SODA distribution has been proposed by Shankar 2016 for analyzing lifetime data from engineering and biomedical science. It has been observed that it performs better than exponential distribution and linear distribution by Lindley 1958 in terms of fit. The distribution can be easily expressed as convex combination of exponential theta, gamma 2 theta, and gamma 3 theta distribution with their proportion value, this respectively. The probability density function of SODA distribution is small f of x equal to this, and the corresponding commutative distribution function is capital F of x equal to 1 minus these expressions. That the generalization of SODA distributions with their PDF and CDF and introducers. A quasi-SODA distributions was introduced by Shankar in 2016. A generalized SODA distributions introduced by Shankar and Shukla and Feshi in 2017. A two-parameter SODA distributions introduced by Shankar and Sheffy. A new two-parameter SODA distributions introduced by Sheffy and Shankar. Another two-parameter SODA distribution introduced by Shankar 2019. A new quasi-SODA distributions introduced by Shankar and Shukla in 2020. Generalized inverse power SODA distributions, Okuli, Osiji, and Onikwar in 2021. Two-parameter weighted SODA distribution introduced by Shankar and Shukla, and two-parameter power SODA distributions given by Shankar and Shukla. A three-parameter SODA distributions. Nikov and Ayok in 2020 has proposed a three-parameter SODA distributions with three of these. It is observed that several statistical properties of a three-parameter SODA distribution have not been studied so far. In this paper, we try to drive and study all those statistical properties of a three-parameter SODA distribution. A three-parameter SODA distribution is a convex combination of exponential theta, a gamma 2 theta, a gamma 3 theta distribution with their mixing proportions, this respectively. Now we may express the CDF of a three-parameter SODA distribution as this. Particular case of a SODA distribution. A three-parameter SODA distributions contain several lifetime distributions for various values of parameters. For lambda equal to theta and alpha equal to 2, it reduced to SODA distributions of Shankar in 2016. For lambda equal to theta and alpha equal to 0, it reduced to Lindley distribution. For lambda equal to 0 and alpha equal to 2, it reduced to Akash distribution. For lambda equal to 1 and alpha equal to 0, it reduced to Shankar distribution. For alpha equal to 0, it reduced to quasi-linear distribution. And for alpha equal to 0 and lambda equal to 0, it reduced to exponential distribution. That is the graph of the distributions. And that's the graph of the CDF of the three-parameter SODA distributions. Now comes moments. The Rth moment about origin of three-parameter SODA distribution can be obtained as in this form. In mu r dash, we putting r equal to 1, 2, 3, 4, we get the raw moment as mu 1 dash, mu 2 dash, mu 3 dash, and mu 4 dash respectively. Yes, sir. It is the hazard rate functions. That is the graph. From the graph, it is observed that the hazard function is increasing function. The Lorentz curve is obtained as this form. Sir, and the maximum likelihood estimations we have. First one, L is likelihood function is expressed as, and x1, x2, xn be a random sample of a three-parameter SODA distribution. The likelihood function L is given by the maximum likelihood estimate of theta cap, lambda cap, and alpha cap of theta, lambda, and alpha are the then solution of the following nonlinear equation are this. And these three natural likelihood equations do not seem to be solved directly. However, the Fisher scoring method can be applied to solve these equations. We have the following equation can be solved for maximum likelihood estimate by these equations. Application parts. Data set 1, the real data set discussed by the Elmongi et al. 2021 that represents a COVID-19 mortality rate data belongs to Mexico of 108 days that is recorded from 4 March to 20 July 2020. This data form of rough mortality rate, the data are as follows. And second dataset is the following bimodal dataset discussed by Gitani et al. In 2008 is obtained from the banking sector. The waiting time in minutes before the customer receives service in bank. The values are this. That are the table of MLE estimate minus twice local AIC, AICC, BIC of the distributions for the dataset. So from the table 1 and table 2, we observe that weighted Sousa distribution and a 3-parameter Sousa distribution have the least minus twice log L, AIC, AICC, and BIC values as compared to others. That is the conclusion of, since Sousa distribution is a very new distribution introduced in the year 2016, and so several generalizations have been done, different researchers try to extend modified generalized Sousa distributions to fit lifetime data. A 3-parameter Sousa distribution has been studied in detail along with application with various statistical properties like moments and its related measures, hazard rate function, cumulative hazard function, inverse hazard rate function, Mills ratio, and mean decimal function. Yes, sir. Yes, sir. The goodness of fit of the generalization of Sousa distribution shows that weighted Sousa distribution is the best distribution, and then a 3-parameter Sousa distribution is the second best for real lifetime data. That are the reference. And then thank you, sir. Thank you, sir.
హలో. ఇప్పుడు ఆన్లైన్కి వచ్చానండి. నో 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 నేను తర్వాత ఐ చేంజ్ ఇన్ మై ప్లాన్ అండ్ ఐ హావ్ కన్వర్టెడ్ టు ప్రొఫెసర్ రావు. అది ఓకే. ఓకే. షూర్, నో ప్రాబ్లం. Yeah, thank you, Lavanya. I hope I'm audible. Okay, thanks for the introduction. It's a proud privilege for me to participate in this conference. I'm the product of Andhra University. I'm proud student of that particular institution, and I'm the student of KSR as well. Okay, we have two technical talks. I hope, Lavanya, all the speakers are there.
Yes, sir.
Yeah. I welcome Dr. Amar Singh.
Thank you, sir.
He pursued PhD in agriculture statistics from Achyuta Narendra Deva University of Agriculture and Technology, Ayodhya, UP. His total teaching experience as an assistant professor is more than 7 years. He is currently working as an assistant professor and HOD of agriculture statistics. And then he has 17 research papers to his credit in various peer-reviewed journals with a NAS rating of 5.46 to 4.16. Okay, I welcome Dr. Amar Singh for his presentation. Invited.
Thank you so much, sir. Thank you, sir.
Yeah, welcome.
Sir, my slides are visible?
Yes, they are visible.
Thank you, sir. Good morning to all of you. It is my privilege that organizing committee give me opportunity to deliver for invited talk in this wonderful international conference. And my research topic is estimating and modeling of rice creation region in time of India. In India, rice production is an important part of national economy. Our country is the second largest producer of rice in all over the world and also largest exporter of rice. Rice is the main grains of food of India. Furthermore, this country has the largest area under the rice cultivation as it is one of the principal food crops. It is in fact the leading crop of country. Rice is a rudimentary food crop and being a tropical plant, it complements comfortably in a hot and humid climate. Rice is primarily grown in rainfed areas that receive heavy rainfall. That's why it is basically a kharif crop in India. It needs a temperature of about 25 degrees Celsius and above, and rainfall of more than 100 centimeter. Rice is also grown through irrigation in those areas that receive comparatively less rainfall. Rice is the principal food of eastern and southern part of India. These are the reviews of literature which I have been taken. According to Rahman et al. In 2016, they forecasted us rice area and production data commencing from 1971 to 72 to 2013 to 14. They observed that ARIMA 115 and ARIMA 114 model were performed better than the other ARIMA models for forecasting us rice areas were forecasted 1041.2 1041.2 and 499.31 thousand hectare, and for production it was 2059.642 and 1781.545 thousand metric ton in 2014-15 and 2023-24 respectively. Like that, Rahman, they carried out in their paper that the forecasting capability of feed-forward neural network model and Box-Jenkins method, which were among those forecasting models most successfully applied in practice. They investigated the application of neural network model and result of which compared with those obtained by the Box-Jenkins method. Earlier, Rahman also examined in 2010 the best fitted model ARIMA that may be used make efficient for cost boro rice production in Bangladesh from 2008-9 to 2012-13. Rahman studied that local model, modern and total boro time series are first order homogeneous stationary. He found from the study that the ARIMA 010, ARIMA 013, and ARIMA 012 were the best for local modern and total boro rice production respectively. It was observed from analysis that short-term forecast are more efficient for ARIMA models. The autoregressive integrated moving average, that is ARIMA, methodology developed by Box-Jenkins in 1976 have been used by the number of researchers for forecast demand in terms of internal production, consumption, imports and exports, like that. Then I will move for material method. For this present study, we have taken 7 major states for analysis to
I got the form.
of rice, namely Andhra Pradesh, Chhattisgarh, Karnataka, Punjab, Tamil Nadu, Uttar Pradesh, and West Bengal, along with the whole India are considered. Data associated with rice production in 7 major states could be acquired from year 1997 to 2018. To express the pattern and general trends in data, descriptive statistics are helpful. It comprehends numerical and graphical procedures to summarize the data set in reasonable and understandable manner. To look at every series nature, these have been uncovered to diverse descriptive measures. Some important statistical measures are used to calculate the series, such as mean, standard error, skewness, kurtosis, maximum, and minimum. The ARIMA was chosen as the best model for forecasting the rice production for these criteria is given as highest adjusted R square, lower value of economic information criterion that is called AIC, root mean square error, mean absolute percentage error, and thigh U inequality coefficient. When the model satisfied the conditions, it is used for forecasting purpose with the help of R software. ARIMA models were estimated for rice production based on the best model forecasting has been made up to 2028. These are the criteria and formulas. You can see R square, RMC, MAE, MAP, thigh U, and AIC. What is the autoregressive model? Autoregressive model is the generalization of ARIMA model in time series analysis. Integrated means the trend has removed and no significant trends mean the model in ARIMA model. In this study, the ARIMA PDQ model is considered. It has 3 sections. AR, that is P. Some portion of model shows the autoregressive procedure of order P. This can be written as this, where xt equal to production of rice at t time xt1, xt2 up to xtp is the production of rice at lags t minus 1, t minus 2 up to t minus p, and alpha naught is the constant. Alpha 1, alpha 2, and alpha p are the parameters of the model, and mu t is the error term, that is mu t follows normal distribution with mean 0 and variance sigma square respectively. In the second section of the model, D implies contrast. For example, on non-stationary data at that point, it's changed into stationary, and as it is the primary rule for creating the ARIMA model. The notation MA, that is Q, refers the moving average series of the order Q. You can see where theta 1, theta 2, theta Q are the parameters of the model. Mu is the expectation of XT, and epsilon T is the white noise error term at that time, T time. Epsilon T minus 1, T minus 2, epsilon T minus Q is error in preceding time frames that are fused in the response of XT. ARIMA model, these are the ARIMA model. The time series xt is a ARIMA PQ model. If xt is essentially for all t, the xt gamma 1 xt minus 1. You can see this equation follows follows normal distribution with zero mean and variance sigma square, and this polynomial have two common factor and respectively like that p and q, AR and AR and MA also. ARIMA model in the time series xt is the ARIMA PDQ model. If yt equal to 1 minus k to the power d xt is a0 or a0, ARIMA PQ procedure. It means if xt satisfies gamma asterisk k xt equal to gamma k 1 minus k to the power d xt equal to theta k zt, where zt now follows the normal distribution with mean 0 and variance sigma square. Gamma z and theta z are polynomials of p and q degree, where gamma z is not equal to 0 for all modulus value of 1 and z equal to 1 polynomial. Gamma asterisk z has 0 of order d. The process of xt is stationary if d equal to 0, and in this case it decreases to ARIMA PQ process. Given a lot of time series data, one can compute the mean, variance, ACF and PACF of time series. This conjunction permits us to look at assessed ACF and PACF, which gives all those regarding the correlation between the perception satisfying signifying the subgroup of models to be interested. The techniques finished by the taking look at the cutoffs in PACF and ACF at the recognizable proof stage. One would attempt to coordinate the evaluated ACF and PACF with hypothetical ACF and PACF as a guide of effective model determination. However, an ultimate choice is made once the model is assessed and analyzed. ARIMA has 4 major steps as model building and identification, estimation, model diagnostic, and forecast. Firstly, tentative model parameters are identified through ACF, that is autocorrelation, and PACF means partial autocorrelation function. The best coefficient for the model are determined through MSE, MAP, etc. Next steps involved is to forecast and finally validate and check the model performance by observing the residual through L-Junk box test and ACF plot of residuals. From the table 2, that is where is table 2? That is from the table 2. We find the India. In India, the production of rice has increased from 1997 to 2008. 63.2 million tons. In the stability shows the 1,000 million tons. I'm telling in million tons. 63.32 million tons to 118.68 million tons. The average yearly production of rice is 95.36 million tons per year, and the kurtosis value of whole India is minus 0.18 of production, indicates that the kurtosis nature followed by the negative value of is given as minus 0.19. Which indicates a continuous effort was there to decrease the yield of rice. State-wise figure shows that in Andhra, in Andhra Pradesh, the production of in 7.0 million tons during the period varies from 7.32 million tons to 14.41 million tons. Although Andhra has fourth rice production ranks with an average 10.46 million tons production per year. The production of rice has increased 6.53 million tons from the period, and 2.25 million tons to 8.7 million tons in Chhattisgarh. Like that, Karnataka state production of rice has increased 2.08 million tons from the period to 2.39 million to 4.47 million tons. Karnataka state has lowest rank in rice production with an average production of 3.55 million tons per year. Punjab, like Punjab state has 5.4 million tons from period and 7.90 million tons to 13.38 million tons. Punjab state has third rank in rice production with an average production of 10.47 million tons per year. Tamil Nadu state production of rice has increased 4.99 million tons from the period 3.22 million tons to 8.21 million tons. Although Tamil Nadu state has the fifth rank in rice production with an average production of 6.00 million tons per year. Uttar Pradesh state production of rice has increased 6.42 million tons from the period and 9.59 million tons to 16.01 million tons. Uttar Pradesh state has second rank in the rice production with an average production of 12.49 million tons per year. West Bengal got first rank because West Bengal state production of rice has increased 4.07 million tons from the period 12.42 million tons per year to 16.50 million tons. West Bengal state has a first rank in rice production with an average production of 14.65 million tons per year. The negative value of quotas for major state as well as whole India clearly reveals that there has been sustained effort in augmenting per hectare yield of and in table 3 shows all model selection criteria results obtained using parametric trend models after assessment of each and every trend series. We forecast the series for forecasting ARIMA PDQ methodology as discussed in material and method session. Data for the period 1997 to 2018 were used for model building. Best model are utilized to predict the series are seen fitted with various ARIMA values. This is ARIMA 100, ARIMA 110, ARIMA 001, ARIMA 010. These are the ARIMA best fitted models. These models are seen best fitted model for rice production in India and selected states. In table 4, these are table 4. These tables are state wise. This table are state wise. All are table 4. These are Andhra Pradesh prediction from forecasting values to 2019 to 2028. Chhattisgarh, Karnataka, Punjab, and Tamil Nadu, Uttar Pradesh, West Bengal, whole India. We are seeing after seeing predicting value, The models rice production prediction for the year 2028 was 136.2944 million with the range of 110.46 to 162.12 million tons limit for whole India. The variety of predicted values can be checked when for possible. Similarly, forecasting figures these are forecasting figures. Yeah, the Andhra Pradesh state forecasting figures is and then equilibrium state. Chhattisgarh state are also showing almost in equilibrium state. We have selected 7 major states, but only Punjab state showing the increasing trend for forecasting, and also whole India. Also whole India, we can see this is the increasing order. So finally, we can say it may be concluded from the present study that different ARIMA models fitted better for the rice production in whole India, and selected major states in terms of all the highest adjusted R square, lowest value of AIC, MAP, and Thiel U inequality coefficient. It is also concluded that rice production will increase in future, and it would be for year 2028 to be 136.2944 million tons in the whole India. Similarly, Punjab state also has been increased production while the rest of states state in the upcoming years 2019 to 2028. These are the. Thank you, sir. Hello. Thank you, ma'am.
Like applications of from 2017 onward, right? Yeah, I'm online only. Hello. Hello.
Yes, sir.
Yeah, am I audible?
Yes, sir.
Okay. Yeah, thank you very much. It's a wonderful presentation. Okay, like you have prediction data from 2019 onwards, right?
Yes, sir.
Okay. Now the data of 2019 and 20 must be available in the open domain.
Yes, sir.
Have you checked the correctness of your estimates?
Sir, the data, I have downloaded the data from Directorate of Economics and Statistics, Ministry of Agriculture and Farmers Welfare.
Okay.
Yes, sir.
No. Yes, that's true. Say your predictions are there from 2019 onwards. So
yes,
the real data from 2019 must be available in the open domain now. So
yeah, approximate. I have checked. It is approximate same as my prediction. Almost same.
Okay.
Not exactly.
Okay.
Almost same.
Okay. And are you? I mean, why you're not thinking of applying any other techniques in the sense of machine learning and other approaches? Have you tried?
I am working on it. Sir.
Okay.
For same data, I am working on it.
Okay, wonderful work, Dr. Amasik. Nice interacting with you.
Thank you so much. Thank you.
Okay. So let's go to the second talk of the next talk of the day. Let me welcome Mr. Dr. Gadhia Venden. Is he available? Hello. Hello. Yeah, next speaker is available. Gadhia Venden. Dr. Gandhia. Okay. Dr. Venden. Lavanya, can you contact on his mobile otherwise? Dr. S. Gandhia Venden, please. Am I audible?
Is my audible, Professor? Hello.
Hello.
Audible, my voice?
Yes, Dr. S. Gandhia Venden.
Okay. Yep.
Shankar, I'm session chair. I warmly welcome you.
Thank you, Professor.
Yeah. Dr. Venden, he did a PhD from Bharatiya University, Coimbatore. He has research experience from 2002 to 2014. Okay, he achieved the International Education Award for the Excellence and Excellence Faculty Award in 2021. He was project associate in Six Sigma Master Black Belt from ASI from 2008 to onwards. I could see so many like he's MTech in IT, MBA, MSc, MPhil, PhD, postdoctoral fellow from IIT and ICMR. Okay, nice to have you here. Okay, welcome. Go ahead, sir.
Thank you, Professor. Thank you very much, Professor. First of all, I thank to Professor Tirupati Rao, sir, and Professor Muniswamy, sir, head of the presentation of this. And also, I can say, sir, conference organization, team, different universities. Recently, I got international nomination of country coordinator. International Statistical Institutions recently. This duration is if I start my session for cognate Internet of Medical Things and IEF for model mixer.
Please go ahead.
How to contribute from the healthcare sector to cognitive applications for the IoT technology and the expertise of the industrial application available to the collaboration and the increase of the business equipment. Based on this combine, the different perspective is biomedical engineering, bioinformatics, and the genomics application for the pipeline of advance in the sequencing technologies are amplifying the role of the genomics and the clinical applications. The different perspectives going this happen to be here. what kind of things is there? The Internet of Medical Things, the next generation analytical tools, the biomedical devices for the software applications for the human health measurement. In this review, discussed with the past review of lectures, the existing process and the proposed process. The importance of the artificial intelligence, it is not a facility, it is different domain is there. Artificial intelligence improve the capability of the IMOT, Internet of Medical Things. The focus for the point of care is the healthcare application. Such as different sector is there. Diagnostic function, diabetic mechanism, lot of other things. The artificial supporting the robotic surgeries is developed for the advanced biomedical applications in this my presentation function. Viewed, also the encompasses to the technological and emerging challenges and the perspective of the artificial intelligence based on the cloud integrated personal IMT. It's related to the data insights and also the data fusions. Data fusions is to accumulate with cloud function the recently developed methodology. Next, during the process is any kind of things is happening for the smart sensor network. During the latter 19, it's one of the IBM corporate sector Inc. to develop the artificial machine models. In mid of 2020, the social network platforms and the email service providers for the several engines is there. The based on the two algorithms they're using for the technology, cluster algorithm and the associated algorithm. The cluster algorithm is the data in the cluster based on the similarity, such as the purchase behavior of group of customers, helping the market trend. Next, for the association algorithm, is the rolling the lane of the algorithm to find the relationship variable that is data sets, different kind of such as the data insight, data on function. For example, the shopping patterns of the individual customers to suggest the product of customer to customer. The reinforcement learning is the reward of the penalty based in the learning methodology. Algorithm assigns the positive values to the desired result and the negative one. Whatever may be, each result is the positive or negative is not different. The how to affect with the corporate input. The knowledge based on the training, the deep learning model. The retrieve the input data sets obtained from the clinical trial data is recently development. For example, fMRI, the functional magnetic, it is one of the CT scans. The data collected from the Alzheimer's patterns and the lung cancer computed from CT scans. The user input to the file artificial assistant the diagnosis of the agents and the lung cancer. It is one of the examples. It is not a developer perspective. Another further review of the paper is exploring the advancement of the development of IMT and the artificial assessment platform with the cardiac monitoring, cancer diagnostics, surgery, diabetes, and also whatever sample. Next was the role of the nanotechnology and the IoT, IMOT in healthcare. The thinking point, the pink environmental healthcare solutions, including the nanomedicines and the nanorobotics, is a very important of the situation of the current scenario. Applications, the device, the interlink the broad category of the research area, include the nanotechnologies and the biomedical engineering to challenge the diagnostic therapeutics, surgery and the drug therapeutics. In advances of the function of materials such as grapho, phospho, and MX genes enable to the generate the next generation of biosensing devices which improve the spatio-temporal features. Is XMI is one of the next sequence generation applications is biomedical technology, biomedical engineering, healthcare application. It's specifically for the tools is the app is developed for the integrated e-skin based on the sensor the monitor human motions based on the processor and the application, nanotechnology application. Next for the another application, machine the ML to allow the tackle the sensor to improve its accuracy. It is our minimum point. It is not exactly perfect value. It is one of the minimum value. 80% to identify the surface, the structure, and the material is the tie up with the aerodynamic application, the range application. The electronic properties of the graphene enable to the construction of the electronic noise sensor that developed in the gas sensor of the maker, the human architecture. One of the intellectual portion also and of the team developed the artificial system noise for detecting the violating organisms into the graphene-based. Next, for the ML approach, one of the training is the creating new engineering biorestrictive molecules for the intelligent sensor application. This is one of the R&D DNA related. In ML, predicting and recognizing the ability to the report in a service environmental activity and facility of the. Another for the deep learning related to the deep neural network, the algorithm to design and analyze the performance of RNA. The first time in global level, the China is 3 years, 5 years ago, the edited for the DNA RNA is first time. The based on the modeling, next generation development models and help understanding the synchronous of system the behavior of function. Next for the surgery, role of surgery in IMT healthcare. The IMT is rapidly increasing due to the development combined growth, artificial intelligence, machine learning, whatever something is. Several such of applications like artificial intelligence, machine learning, computer vision, deep learning, and NLP, neural language with language perspective. Next, how to artificial intelligence help us the focus divide the risk in the how to reduce the risk in the situation of surgery level. The automatical information, genetics, and other historical of the history, it is the examination of the patient examination. And the economics of the patient, the social behavior of it, the and to take the make better predictions of the some of the one of the disease, it can be predicted to the DL, the deep learning model, due to suture the patient the better benefit from the surgery. The AI can be provided the direction to surgeons, if any clinical surgeons, surgeons into the operations room so that the surgery can be performed within the minimal risk. That based on all collection of data from the hospital EMR records, the blood pressure and the glucose decision support system is algorithm, and DSS algorithm is the input of the training refrigeration. It's very backbone of the surgery minutes. Next for one of the kind of things is the decision prediction algorithm. How to decision the prediction model, the decision prediction algorithm, including the K nearest model and the same model. Decision tree is the data structure algorithm of the decision tree. It is aid to the clinical features from the overflow of the data sets. The next generation device would allow the efficient process of the both noise reduction and the data management. It is a mobility function. It is not a standby. It mobility has opened new avenues of the IoT healthcare. The scope of the mobility IoT is nowadays is COVID time is very famous of smartphone use devices. The mobile healthcare is enabled to the telecom to bring the IoT whatever analysis. Next for challenges, role in the challenge in the future perspectives the health world. For artificial intelligence advances, diverse the healthcare sector such as monitoring, prediction, diabetic management, and the surgeons have been the reported. Next, the ML to process extensive complex systems and data effectively from the further analysis to the decision making ability. The both of complex artificial intelligence and machine learning also help the extract the analytical data from low resolution or noise data, how to clear the exact redundant functions of the techniques allowed by MOT devices to extract the hidden information based on the relationship between the sample parameters and mathematical signals. Next, the techniques for the improve the signal sensitivity, the specification of mathematics. Next, for the IoT vital functions is the device situation. The connectivity can be unidirectional and bidirectional function. It's based IoT sensor signal must be processed before the being sent as a microcontroller process, whatever may be associated with the encryption legal application, the digital data. Now the encryption is how to measurement to the analog contains eliminates the bulk electronics of the signal conditions of the function. The connectivity between the analog front-end applications and the microcontroller is usually the development of protocols with several functions. The reports based on the recent developments and advancements is mainly to the artificial intelligence and IoT devices, the efficient biosensor need for the success disease management of AI, ML, DL, whatever may be associated with the IoT. Discuss with the significance of the nanotechnology medical devices. Yes. Nowadays, the thieves can, whatever maybe it takes the wearable devices is going to the presence of military, another thing is for Internet of military things is the use of the texas of functions using for the materialization. Now, the integrated device are important to the crucial medical areas such as the cardiac monitoring, surgeries, diabetes, cancer monitoring. Through the cloud computing is the data fusion and the data insights. It is function. It's the technology. Some of the kind promotes the monitoring the cardiac applications, the imaging, the presence, mathematical things, and also invariant made by the artificial intelligence sector is to the all kinds of things established to the quantum shift to the diabetes cancer function. It's based on the outcome support from the earlier predictions determine the level of the risk available to these things. It's how to reduce the time using for the statistical application. It's major functions of how to reduce the risk identity function is one of the role in the Six Sigma application. It is very important role. If this is the Six Sigma application is developed using the engineering system, using for the discount. The many physicians prefer the machine learning algorithms and for predictions because the data is accurate. Besides the ML or a subset of the neural network, whatever may be used in the clinical sector. Every innovation has challenges such as artificial intelligence, heterogeneity, connectivity, and actions by automated issues. It is difficult to pursue. The solutions of these, the problem have been discussed with this paper, additional presentation of the review functionality. This start coming of this, the excellence of the medical field, the outcome continues evolution. Its outcome in scope of output the motivation the young researchers to promote and the investigative of the combination of approaches involving the nano-enabled sensing, artificial intelligence, or efficient difference and the need for the diabetes control and the management in the personality management development of function. Now happen to be the two is outcome of things is there, what kind of benefits is there, remote sensing, diabetes, reducing the spending management, and all of the research benefits also benefits IoT. Next for thinking of IoT applications, Internet of Boss, smart software, smart labs, what are we going to teach here in the system. All kind of things how to associate with the different thinking function. Is non-linear of functions, iterative process, that is the understanding the user challenges of functions involving the measurement of things, how to analyze of things. for a data analysis. You begin to take the first step, the world of the data analysis, learning to the details about all the concepts and the process to make up the disciplines. Where this concept or the process will be able to the form with whatever may be Python code. So through the several libraries, it will be the description. In the world increasing the centralization around the information technology, huge amount of data projects of the storage every day. Often these data come from the automated data support and sensor and the scientific instrumentation. Or you produce them daily and unconsciously every time you make the withdrawal from the whatever may be bank or the purchase. This process is extraction with the raw data for the data analysis. The purpose of the data analysis to extract the information that is not easily detectable, but is very understandable that the lead to the possibility of carrying out the studies the mechanism of the system to the healthcare center of basis. The model fact that the success in the statistical form of the system pushes the studies. That's the aim to the data analysis, not only a model, but quality of predicting power. That show that the search for the data extraction and the subsequent preparations while the constitution is also the kind of the data. In case the belongs to the data analysis itself, because their importance to the success of the result, the IoT functions. In parallel to the all stages processing to the analysis various methods data visualization have been developed. Over the year of large display models, the mode of kind of things have been developed for the different functional test space, whatever can be prediction model, it is however maybe happen to be the success. Once we have the assessed the last phase of the data analysis, this based on the predictions generated model for the risk for association methodology. The data analysis will suit to the many professional activities if follow to the hypothesis the deeply development of the measurement. Known of the domain for the data analysis. It is very important. Data analysis basically defines the suitable. Moreover, the computer science, engineering, and information technology they using for the concept is the requirement system in our department, machine learning, artificial and professional field of aspect. Understands the data, whatever maybe kind of things is happen to be here. The data analysis process, how to systematically the problem solutions. When getting the process data analysis, the data extraction, deep learning, the exploration, visualization, prediction model evolution, deploy the measurement of things is happen to the IoT application. So the data analysis, the schema analysis as a process chain consists of the following the sequence for the problem definitions, preparation for data cleaning, preparation for data transmission, exploring the visualization, the model value of deploys with whatever visualization, interpretation result. Is there whatever data is we know that we are satisful portion. This the data analysis associated with the develop the projects that they are compliant with the web server possible to integrate the web application is there. How much the learning advanced methodology, further learning, built the robust deep learning based on the recruit the large quantity of device trading data. In this result show that the IoT application, in this result show that the model trained the further learning performance average better than the counterpoints trained than the institutional local data. Further come, we show that the relative improve the model generalization when evaluated to the other prospects of the functions. In the study, the investigators of the built the medical imaging classification models in a real-world collaborative settings, where several clinical institutions from across the world joined the FL efforts to the train the model is the breast density classification based on the breast imaging reporting data mechanism. So that is the dispute of sustainable differences among the data sets from the all sides the mammography systems, classes, distributions, and the data set size. And without centralization data, we can't artificial whatever maybe another things is that. Now for the information extraction, is the automatic retrieval the specific information related to the selected topic from the information extraction tools. They make the possible the full information from the text document database website and the healthcare data function. The extraction means the pull out, the retrieval means they get back. It is one of the main is like that. While the information extraction is more about the extraction knowledge for the relationships and not set up the document. Information extraction is the standard process of the taking the data and the extraction structure information from the so that the process is the measurement of things is structured in whatever maybe is happen to be the now the develop the functions as identical the analytical data source and big data analysis to enable development the precision medicines to sort of customization treatment planning the execution for the individual patients using the real time and remote monitoring. Therefore, IoT things, whatever may be data management processes in the hospitals, the solution and engagement of flows and the staff will improve the connection of the functionaries to evaluate the measurement of function. It is one of the thing is happened to be the recent development of functions. If, for example, is digital classification, whatever may be, whatever I think is the one of the digital biomedical data, cardiac exploration, artificial interpretational data, advanced clinical the practical. The three kind of I just the it's more than a lot of application is there. The biomedical data exposures of systems, smart mobile phone EMR. The modern deep learning systems, the traditional machine learning systems, the advanced of clinical practice, the enhancement of the several functions is there. Outcomes, the novel disease that I think this is due to some reason.
Yeah.
Thank you, Professor. Thank you very much.
Thank you, Professor Wendell. It's a quite informative talk. You covered the whole journey of the entire technologies behind the cognitive internet of medical things and information extraction. Okay, thanks. Thank you very much. Any questions from the other delegates? Other delegates? Any questions?
No, sir.
Okay. Otherwise, I have a question like Dr. Wendell. Do you have any personal research experience in this particular domain? Have you worked on this cognitive internet of medical things?
Yes, Professor. I have done one of the projects in the situation of scenario. One of the app is development the healthcare products. Real-time Indian surgery. One of the app is there.
Okay.
And it studies 3D printing. 3D printing the gastrointestinal the traditional healthcare is there. Biothesis, bionics, crafters. 3D printing technology, the area.
1 minute. I would like to understand is that additive manufacturing, 3D printing, and this Internet of medical things. What's the relation between them?
Yeah, yes, sir. Yes, sir. This is for the one of the graph 3D action from the surgery planner. Indian Meditech startup. We are the one of the collaborator of things. We provide for the solution for the surgery plan. It's utilizing the radiology assistant 3D model technology to visualize the pattern autonomy, patient's autonomy period to the surgery. The function for the visual surgical platform to assist the doctor in predetermine the surgical and specific implementation with informed evidence from the nearly 10 successful case studies on the complex surgery. Is fully development for the IoT healthcare. It's Indian. We are the proud of the Indian company.
Excellent. Very good. So thanks a lot, Dr. Wendell. So with that, the invited talks for this session are over. Okay, Lavanya, shall we go to the paper presentations?
Okay.
Lavanya? Hello? Yes. Okay, fine. So
thank you,
the first
I have once again thanks to Professor Tirupati Garu and Professor Moichami Garu. Then also for my one of the scientists from ISRO, Professor Dr. Sangar. Thank you, sir. Thanks so much.
Welcome. You're welcome.
Thank you very much. Thank you.
Okay, fine.
Can I leave?
Yeah, it's up.
Okay, nice.
The first, I think, in this session we have 8 papers are there, and we are already late by 7 minutes, I believe. Okay, what we will do, 6 minutes we will give to each and every participant, and 1 minute of question answer session. Is that okay, Lavanya? Yeah, yeah. Okay, the first presenter is Mr. Banot Viranna, and his topic is a note on goodness of fit test for bivariate pseudo Poisson model. Mr. Banot? Yeah. Oh, fine. Welcome. Yes, go ahead, Viranna. Your 6 minutes will start now. Oh, you are from University of Hyderabad, you see? Good, good. Yes, yes, you are audible. Please go ahead. Yeah. Mr. Veerana, this is the last 1 minute for you. Last 1 minute, please. Yeah. Thank you. Thank you, Mr. Veerana. Nice presentation. Any questions from other speakers, other delegates? So otherwise, Mr. Veerana, like, what is the application scenario for this bivariate pseudo Poisson model? And no, what is the application scenario where this okay. Thank you. Okay. 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 Thank you. So we move to second presenter. What's the name? Mr. Chaco and Anaka.
Hello, sir. Am I audible?
Yes, yes, you are audible. And their topic is comparison of different progressive type 2 censoring schemes on exponential power data.
I think
So
my
you have
slide is
6
visible.
minutes time. You have 6 minutes time. Okay.
Okay, sir, is my slide is visible?
Yes, 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 visible.
Okay, sir.
So your research scholar at St. Thomas, Thrissur, Canada. Nice.
Yeah.
Good.
Yes, yes.
Okay. Go ahead. Your time
Okay,
starts now.
okay. Okay, thank you, sir. Good afternoon, everyone. Myself, Anaga. I'm a research scholar of Department of Statistics, St. Thomas College, Thrissur, Kerala, under the guidance of Dr. V.M. Chaco. My topic is statistical estimation of exponential power distribution on different progressive type 2 censoring schemes. Is not. Oh, okay. These are the contents I included in my presentation. Introduction. In many life testing and reliability studies, the experimenter may not always obtain complete information on failure times for all experimental units. And there are a lot of situations in which the removal of units prior to failure is pre-planned. The data obtained from such experiments are called sensor data. The major reasons for censoring is to save the total time on test and to reduce the cost associated with it. The type 1 and type 2 censoring schemes are the commonly applied censoring schemes in practice, but these schemes do not have the flexibility of allowing removal of units. The progressive censoring scheme permits the withdrawal of experimental units at various stages to reduce the total cost and the time associated with the experiment. And it was first presented by Hurd in his PhD thesis. Progressive type 2 censoring scheme studied by many others. Bergstad pointed out that progressive censoring has a greater conventional type 2 censoring scheme. To overcome the disadvantage of progressive type 2, Kuntu and Chaudhar proposed progressive type 2 hybrid censoring, which have fixed experimental time t. In this scheme, we are likely to encounter a very small number of units. It can be 0 because the sample size is random. Therefore, in many real-life scenarios, statistical inference cannot be employed. As a result, NG et al. Offered a novel censoring scheme called Adaptive Progressive Type 2 Censoring Scheme. Now, Progressive Type 2 Censoring Scheme. Here, the experiment is set up with n units. When the first failure occurs, R1 of the remaining units are randomly removed. At the time of second failure, R2 of the remaining units are removed. And the procedure is repeated till the predetermined m failure occurs. Here, the value of R is predetermined. The equation 1 gives the likelihood function according to PT2 censoring scheme. Progressive type 2 hybrid censoring scheme. This is very similar to progressive type 2 scheme, but apart from that, the experimental time t, and the procedure will continue until either the mth failure or the time point t is reached. So we have here two cases, the case 1 and case 2. 2 and 3 are the likelihood function corresponding to both cases. Next, adaptive progressive type 2 censoring scheme, APT2. Here we are fixing the m, n, and r. Time t, that is an optimal overall test period, but we can extend the experiment beyond time t. If the mth failure happens prior to t, the study will terminate at the time. Instead, if the experimental time reaches t, but the number of observed failures does not reach m, we should stop the study as quickly as possible. Till the mth failure happens, the survival units will not be eliminated. Equation 5 gives a likelihood expression for the APT2 censoring scheme. This presentation mainly focuses on the three censoring schemes and how they will work in the exponential power distribution, which is introduced by Smith and Bay in 1975. The CDF and PDF of the exponential power distributions are respectively equation 6 and 7. Next, we derive the maximal likelihood estimators for the parameters alpha and lambda for the three censoring schemes. For confidence interval, we considered asymptotic confidence interval and percentile bootstrap confidence interval, which is proposed by Efron. In simulation study, the effectiveness of weights method can be determined by comparing the bias, root mean square, coverage probability, and average confidence length for a different sets of parameter values. This table gives the different schemes used in the simulation study. And this table gives the values of the MLE, bias, root mean square, and coverage probability, asymptotic, average confidence length for the different sets of parameter values. From the tables, we can conclude that the bias and the RMSE get smaller when the sample size n and the effective failure numbers m increases, and the value of ACL is narrower for each censoring method. The value of coverage probability in the three censoring schemes maintain its nominal level in bootstrap confidence interval. However, fails to sustain the nominal level in the asymptotic approach. The data analysis, we have taken the data taken from in Padgett, which consists of 100 observations on breaking stress of carbon fibers and are given in table. Complete data, we have constructed the artificial PT2, PT2H, and APT2 sensor data for the scheme 1 and scheme 2. To evaluate the goodness of fit, we have considered Kolmogorov-Smirnov test, Anderson-Darling test, and Kramer-von Mises test. The three-test goodness of fit leads to the conclusion that the adaptive progressive type 2 method has the better fit when compared to other methods because it has lost values for the test statistics and highest p values. These are the table values. Conclusion, we have examined parameter estimation of exponential power distribution under Using the Monte Carlo simulation method, the performance of the MLEs under the three sensory methods are examined. Finally, comparison has been made on the real data set, and the result indicate that the APD2 technique is more effective in terms of goodness of. These are the references. Thank you, sir.
Yeah. Yes, Hanaka, you have completed within 6 minutes perfectly. You have taken the correct time. Now that looks like one more presentation also getting added. That's what you are trying to tell Lavanya. Okay. So our time is much more constrained, looks like. Okay. Fine. Any questions from the other participants? Okay. Otherwise, we will move to next presentation. Excellent presentation, Anaka. Continue your good work.
Thank you, sir.
Yeah. So that next presentation is from Lakshmi R. About the robust regression based on SN covariance estimator. Okay, she's there, Lavanya? Yeah, go ahead.
Good afternoon, sir. Am I audible? Good afternoon, sir. Am I audible?
Yes, you are audible.
Okay, sir. Let me share my presentation.
Okay, Acha, you are also attending offline, online. No?
Yes, I am online. Okay, sir. I am sharing my screen. Is that?
Yes, visible. Go ahead.
Okay, let me start my work. Okay. Good afternoon, everyone. My name is Lakshmi R. I am doing my PhD under the guidance of Dr. Satish T.A. in Department of Statistics, St. Thomas College, Thrissur. Here I am going to present my work, a study on robust SN regression estimator and its performance empirically. Moving on to the introduction. One of the most essential and statistical methods in data modeling is regression analysis. It helps in the prediction of a link between the predictors and the response variable. All the academic disciplines, including social science, health science, engineering, regression analysis mainly rely on ordinary least squares method, which is very vulnerable in the presence of the outliers. There are numerous robust regression techniques, among them some are resistant to. In multiple and multivariate regression analysis, regression coefficients are obtained by ordinary least squares method. In multiple regression analysis, OLS works as minimization of the square residuals. Whereas in the case of multivariate regression analysis, the independent and dependent variables are jointly considered. The location and the scatter of the jointly considered variables are used to determine the OLS estimator. In this paper, we innovatively adapt the multivariate ordinary least square estimates into multiple linear regression coefficient estimates. For that purpose, let me consider the variable of independent and dependent variable jointly as Z. Let mu be the location and sigma be the scatter matrix of Z. Then the estimates of beta and alpha. Here alpha is the regression intercept and beta is the regression coefficient, can be expressed as a function of mu cap and sigma cap as in the equation number 2. One of the major drawbacks of the above mentioned technique is it makes use of classical covariance matrices. They are sensitive to the presence of the outliers in the data. So in order to overcome this drawback, robustification of the classical estimators of scatter and location is important and improve the performance of the estimator. Kunyani and Abraham, in their paper, proposed a robust covariance matrix estimation in multidimensional datasets denoted as SN method, and it is also used for detecting multiple outliers. In this paper, we propose a new robust SN covariance matrix, SN covariance estimate of the joint variable Z. And our proposed method, let capital X be an n by p matrix of size n and p being the number of variables. Then the robust covariance matrix based on the SN method of the matrix S is defined as in the equation 3. Here MED represents the abbreviation of the median. The corresponding correlation matrix of the above defined equation is given in equation number 4. Here Sn of xi is nothing but the robust scale estimator of the univariate random variable x, and is defined below. The covariance matrix mentioned in the above equation 3 is non-positive semi-definite. So in order to make our covariance matrix positive definite, we adapt the work of Marona and Summer. Marona and Summer in their paper describe procedure to solve non-positive semi-definite and obtain positive semi-definite. Similar to their orthogonalization proposed, we adapt the work and that makes the estimator, our covariance estimator, approximately affine equivariant, and we proposed that method in our work. And the resulting robust SN estimate of location and scatter is defined in equation number 4. Here, MAD stands for median, and SN is the univariate Robert scale estimate. And it is the relatedness of an estimator always improve the efficiency of the estimator. Here we have reweighted the SN location and scatter metrics by making use of the robust Mahalanobis systems based on the SN estimator defined in equation 5, and the final reweighted SN location and scatter metrics is obtained as in the equation number 6. Based on the final reweighted SN location estimator in equation 6, we obtain our robust reweighted SN regression estimator, which is defined in equation number 7. In our study, we have analyzed the properties such as breakdown, affine equivariance, and robustness of our proposed reweighted SN regression estimator empirically. Simulation study is done to evaluate the performance of our proposed method, and the results are compared with the Euler's and some of the other robust regression estimators like LTS, LMS, S, MM, and S. For the simulation purpose, we consider the dimension of the variable from which ranges from 5 to 30, and sample sizes which ranges from 50 to 1000. The simulations are repeated 1000 times, and each time parameter estimates are noted. Mainly 3 simulation scenarios are considered in our work. The first scenario is the dependent variable is generated from the normal distribution with the corresponding intercept equals 0 and with a standard normal errors. The second scenario, the dependent variable is simulated from T distribution with 3 degrees of freedom with the corresponding regression coefficients including intercept equals 0 and with heavy tailed errors. And in the third scenario, regression with a normal error, some percentage of the randomly selected observations in independent variables are replaced as normal with the mean lambda into square root of 99th percentile of a chi-square distribution with p degrees of freedom and variance 1, and the dependent variables are replaced as normal with the mean k into square root of 99th percentile of the chi-square distribution with 1 degrees of freedom and variance as 1. Here lambda k are constants which takes the values from 0.51, 1.52, 3, 5, 7, 8 and 10. The percentage of the contamination considered in this scenario is 10% and 20%. We have considered a wide range of lambda and k constants so that we can assess and compare with the other estimators. Considering the first property, efficiency, it is a well-known fact that the ordinary least squares have the maximum efficiency under normal errors. Thus, under normal error case, that is the first scenario defined above, the efficiency of each robust method is calculated.
Last minute, please.
Sorry, sir?
Last 1 minute. Last 1 minute.
Okay. Calculator related to Euler's and the efficiency equation is given. And in the second table, the table showing the efficiency of our estimator along with other estimators. In the case of normal error scenario and T table, here we can see that our proposed estimator possesses the least MSE than all other estimators. Thus, we can claim that our proposed estimator possesses efficiency empirically, and also we checked the robustness and breakdown property of our estimator along with other estimator for different combinations of sample size, contamination and dimension, and the tables are given. All the tables show that our proposed estimator possesses the least MSE than all other methods along with the Euler's. Also to check, here we have checked the equivalence and breakdown properties. Since the time is restricted, I am moving on. We have also checked the real-life application of our estimator, for which we consider the Belgian phone call data and which was published by Belgian Statistical Survey. And our proposed regression estimator detect the 6 outlying observations correctly along with the MM estimator, which is considered to be as the best estimator and performed well in estimating the regression coefficients. We can see the table showing the values of the intercept coefficient and MSE, and in the table it is clear that our proposed estimator SN possesses the least MSE than all other methods. And the conclusion of our study is classical regression analysis is very sensitive to the presence of contaminator observations. Here we propose a new robust reweighted SN regression estimator. The properties and performance of our proposed estimator are inferred through a wide range of empirical simulation studies, and our proposed estimator outperform other existing robust estimators. Also, it can be used as a good alternative to the classical estimator. Developing the properties theoretically is the future of this work. These are some of the important references in my work, and thank you, sir.
Yeah. Thank you. And you have empirical data based study also.
Okay,
nice. Any questions from other participants? Okay. Otherwise, we'll move on to the next talk.
Yes, sir.
Yeah. Next presenter is Mr. K.M. Shaktivel, and its topic is a new development in extreme value approach for real life extreme phenomena.
Hello,
Yes, go ahead.
myself Nandini, sir.
Okay.
I'm under the guidance of Dr. K.M. Shaktivel, sir. I'm the presenter, sir.
Oh, okay, fine.
Shall I present, sir?
Yes.
Yes, sir.
Your slides, please project.
My screen is visible, sir.
Okay.
Good afternoon to all. Myself Nandini V, PhD research scholar under the guidance of Dr. K.M. Shaktivel, sir, Professor, Department of Statistics, Bharatiya University. Title of my presentation is A New Development in Extreme Value Approach for Real Life Extreme Phenomena. Introduction of my study. Extreme value theory is concerned with the stochastic behavior of the extreme values. In EVT, we need to deal with the events that are more extreme than any of that have been already observed. In extreme value theory is used to model the behavior of maxima or minima in the series. That means the tail of the distributions. It has two significant results. First one is that asymptotic distribution of a series of maxima or minima is modeled, and under certain conditions, the series converges towards the Gumbel, Frechet, and Weibull distribution. Its standard form is that generalized extreme value distribution. These three distributions combine to form a generalized extreme value distribution. This can be used to model for the maxima method, which is a classical method. Then second one is that it concerns the excess over a given threshold method, that is also known as a peaks over threshold method. This results is used to estimating the very high quantities. It can be modeled with generalized Pareto distribution. And then these are some review of literatures. Pickens in 1975 presented a method for making inferences on the upper tail of the distribution, and also he introduced a generalized Pareto distribution. Hasking first used the probability weighted moments to obtain the parameter estimates and quantities of generalized extreme value distribution. Smith proposed the point process view of high-level exceedances over a high thresholds with cluster approach. Davidson and Smith discussed the analysis of extremes of data by modeling the size and the exceedances, occurrences of exceedances. These are my some of the reviews. And then the next one is a threshold selection. Here the threshold selection plays a vital role in the aspects of inference of rare events. Peaks over threshold method is one way to model the extreme values. This approach also called as a method of excess approach. This can be modeled with the generalized Pareto distribution and also with point process approach as well. The POT method selects those of initial observation that exceeding a certain threshold. Then this is the generalized Pareto distribution. The CDF is given in the equation 2 with the two parameters, shape parameter xi and the scale parameter sigma, with the two conditions. When xi is greater than 0, then the domain of attraction will be the ordinary Pareto distribution. When xi is equal to 0, then the domain of attraction will be the exponential distribution. When xi is less than 0, then its domain of attraction will be a short-tail Pareto distribution and also beta type distribution. This is the second approach called point process approach. This is more associated with the variations of excess over a threshold approach. It depends on time and as well as the frequencies. The point process characterizations allows for modeling both the frequency of exceedances over a high threshold and excess above it. Here the asymptotic theory of the threshold excess shows that are under suitable normalizations, this process behaves like a non-homogeneous Poisson process. Its intensity measure is given in the equation 3 with 3 parameters. Mu is the location, scale, sigma is a scale, and psi is a shape parameter. This is our contribution part, adjusted threshold method. We have introduced this threshold approach. The sample consists of m number of observations in n number of periods, that is m cross n number of total observations. Here the periods are of equal sizes and non-overlapping. Let x1 to xn be a sequence of independent and identically distributed random variables here. Now we consider that the periods as Bij, I varies from 1 to k and j varies from 1 to k and I varies from 1 to n. I represents the positions of each periods consisting of j number of independent and identically distributed observations. We have chosen a primary threshold as equal to q3 minus q1. The excess values above that u is considered here, that is ei. I varies from 1 to n. And when we define that threshold, then the above observations are taken here, and then we have fitted another threshold called adjusted threshold here, which is u star. When the values exceeding that threshold, those observations are taken as a special extreme values, which is represented as ES star. ES star which is greater than or equal to U, and ES star is not equal to EI. Then these extreme values can be used to model, used to estimating the return levels as well. The GP and PP approach, that is generalized pattern point process approach, can be used to model this adjusted thresholds, excess values, and the associated return levels can also be calculated. This is the return levels and return periods. When the distribution is fitted, it is possible to find the return periods and return levels, which is important to forecast the extreme events. And then the return levels are given in the equation 4 here. And then there is a graphical threshold selection. There are two methods. One is a parameter stability plot and another one is a mean excess plot. Parameter stability plot, also called as a threshold stability plot. It was developed by Sackroot and McDonald. And then it involves the plotting the parameter estimates of the GPD or PP model against U, again for the range of values of U. The parameter estimate should be stable above the threshold. Yeah, sir. Okay, sir. Thank you. This is a mean residual plot, which is represented in the equation 1. My application part is that monthly rain precipitations of the state of 1901 to 2007, that is 117 years. This is a parameter stability plot. The vertical line which represents the threshold values, then the above which represents the number of excess. And then this is a mean excess plot for POT method to find out the thresholds. And this is my estimated estimation tables, which represents that AT with the PP approach shows a good fit for this excess data. And then this is a density plot. Among this, the figure D, AT with PP approach, which shows a good fit when focusing on the tails of the distribution. This is among this, the AT with PP approach with U value, that is threshold value 565.5, which shows a closer confidence intervals of the return levels associated with its return period. This is a return level plot. And then summary and conclusion of my study is that we have compared the 4 models. Among this, the adjusted threshold with the PP approach shows a better fit for this data set. Our finding reveals that the PP method with adjusted threshold approach is an optimal model for this study. We have also estimated the return levels as well.
Yeah,
These
thank
are
you,
some
Nandini.
of the references. So, thank you, sir.
Thank you, Nandini.
So, thank you,
Okay.
sir.
Any questions from other participants? Okay, one thing you tell me, that example, the problem that you have taken rainfall related data from
Yes, sir.
state of Kerala.
Yes, sir.
What is that real-time extreme phenomena that you found out there?
So heavy rainfall causes a flood. So we are focusing on the extreme values of each and every years, and those extreme values are used to estimating. Then estimating the return levels. That return levels, that is, we have estimating that return levels associated with its period. That is what is the probability of happening these extreme events in that period. We have considered. That is, we have estimating that return level at least 1 times in that period. This extreme levels can be happened, sir.
Okay, have you checked with the previous year's data and applied these 4 techniques that you are talking about and seen the efficiency of your specific method?
Yeah, yes, sir, I have checked, but it is slight difference. But among these 4 methods, our method shows a good fit, sir.
Okay. How did you come to the conclusion that your method is better?
So we have compared the goodness of fit test. In the goodness of fit test as well, this shows a good fit, sir. That is adjusted threshold with PP approach, sir.
Okay, good work.
Yes, sir. Yes, sir. Thank you, sir.
Yeah. Now let's invite the next speaker, Dr. Sandeep Mishra. And his paper is on an improved imputation method for estimating finite population mean. Dr. Sandeep Mishra. Is he available? Looks like Mr. Gyandeep Mishra. Acha, not available. Okay. The next presenter is Varnika, and the topic is reliability single sampling plan based on Poisson-Pritchett distribution.
Yes, sir. Am I audible?
Yes, you are audible.
Is my screen visible?
Yeah.
Okay. Good afternoon, everyone. Myself, Varnika VN. I am doing my MSc Statistics for Christ University, Bangalore. And I'm guided by Dr. Azurul S. from the Statistics Department, Christ University, Bangalore. My topic today, I'm going to be presenting the paper on reliability single sampling plan based on Poisson-Pritchett distribution. Now, what is acceptance sampling plan? So, acceptance sampling plan, we know that it is a quality control technique that uses the rules and procedures for making decisions whether to accept the lot or to reject the lot. So, we have the two types risk involved in the sampling plan, that is alpha risk and the beta risk. So, if the lot does not meet the quality and the lot is accepted, then it is called the type 2 error or the beta risk, also called as the consumer's risk. And if the lot meets the quality and then the lot is rejected, then it is type 1 error or the alpha risk or the producer's risk. Now, what is reliability sampling plan? So, reliability sampling plan, these are the sampling plans that are used in the manufacturing industries to make the decision whether to accept or reject the lot. So, if R1 is the desired reliability, probability of failure will be 1 minus R1. And the lot with probability for failure less than 1 minus R1 will be accepted. And the probability of rejection or the alpha risk. And if let R2 be the minimum reliability, that will be considered just acceptable. Then the probability of failure will be 1 minus R2. Any lot having failure rate more than 1 minus R2 should be rejected. And the probability of accepting such a lot is the consumer or the beta risk. Literature review. So the first paper that for the literature review is acceptance sampling plan from life test based on percentiles of half normal distribution. So here the acceptance sampling plans are developed for percentiles of half normal distribution. That is minimum sample size required to decide upon whether to accept the lot or to reject the lot is on the specified 50th percentile or the median. So here they've taken the lot and they have done the truncated life test on this. So here, for example, taking an example of a bulb, so we cannot wait until the shell of lifespan of the bulb to over. It is not. It takes a lot of time. It is not cost efficient. So the one of the method they go in sampling is for truncated life test. Next is the reliability Olkin extended exponential distribution. So here, this Marshall-Olkin extended distribution is of the form g bar of x alpha f bar of x by 1 minus alpha bar f bar of x. So this is the survival function of the exponential distribution, which is f bar of x is equal to e to the power minus x by sigma substituted in the Marshall-Olkin extended distribution, and then we'll get the Marshall-Olkin extended exponential distribution. So for this, reliability test plan is developed, and decision is made whether to accept or reject the lot. And the lifetime of these are follows the Marshall-Olkin extended exponential distribution. So in the paper like acceptance sampling, next paper, acceptance sampling plans for Burr type X distribution, or the acceptance sampling based on life test log logistic model, and U-Wibble Pareto distribution. So in this paper, the common pattern which we can see is the minimum sample size is been calculated in order to ensure that the necessary certain average life which is there, and the life test is terminated at a pre-SM time t, and the failure which is do not exceed the C, which is the acceptance number. And so my research objective is designing of reliability single sampling plan on Poisson-Fréchet distribution. So now why Poisson-Fréchet distribution? So my main motivation of taking this distribution was it had properties like reliability analysis, it had moments and quantile function which we'll be using to calculate in the later part for calculating the minimum ratio table, so the properties of the Poisson-Fréchet distribution, the PDF and the CDF, which is small f of x comma alpha comma beta comma theta, which is the PDF of the Poisson distribution, and capital F of x comma alpha comma beta comma theta, which is the CDF of a Poisson-Fréchet distribution. So here alpha and theta is a shape parameter and beta is a scale parameter, and here the asymptotic behavior. So when we put limit of x tends to 0 and x tends to infinity for the both the PDF, we get it is at 0, tends to 0. So sorry, it's equal to 0. So this is the asymptotic behavior, and the reliability analysis, which there the survival function, which gives us the how longer our lot like or the subject survives at the expected time, survival function, and the hazardous function which gives us the internal rate of a subject, and the quartile function, capital Q of U, which we'll be using for the calculating in the later part. Next, methodology. So in the paper starting, we have taken the truncated life test consists of the following quantities for n minus I, and here P is our f of t comma tq naught, and here t by tq naught, these all values
Last 1 minute, please.
Yes,
Last
sir.
1 minute.
Yes, sir. These these values are taken seeing the pattern of all the papers. And here operating casting values, which gives us a source how to choose the minimum sample value. So it should satisfy the inequality probability of accepting a lot. And here the OC curve, which we have the plot which I've got, here we can see that the ratio of TQ by TQ naught, which is the qth percentile to specific qth percentile time, is increasing, has the probability of acceptance is increasing, and this for different values of C we have done, and the n values which is taken from the first table. And next, the minimum ratio table, which we calculate using the quantile function, and then substitute the CDF of the function. So it helps us to know the minimum sample size to accept the bad lot at the small probability. So going for the illustration of the table, when we take P star is equal to 0.99 and T by TQ naught is equal to 1.571 and C is equal to 3, we can see that the corresponding table value was n is equal to 24. So from this we can get to know that out of 24 items, 3 or less are fail before time t, then the lot can be accepted with the probability of 0.99. And for next, the operating casting value for the sampling plan n comma c comma t by tq naught, which is 38.2 comma 1.57. For
Please
TQ,
conclude.
yes,
Please
sir.
conclude.
T by tq naught being 2, we get 0.4871. So here we can see that the true mean life is twice the specified mean life, and the produces 0.51618. So the conclusion here, truncated life test for the Poisson-Fréchet distribution is proposed, and the minimum sample size using both Poisson approximation and binomial approximation is calculated, and operating casting value, which helps us to know how to choose the minimum sample size, we'll get to know, and the minimum ratio table, how to accept the bad lot with the small probability is calculated. Yeah, that's all from my side. Thank you.
Thank you, Varnika.
Yes.
Any questions? It's nice to write and present a paper at the MSc stage itself. I congratulate you for that.
Thank you, sir.
Yeah.
Yes, sir.
One thing is, have you applied it in any
Sorry, sir.
scenario, or have you applied this in any application scenario?
Like we can apply, not yet, sir,
No.
but we can apply for the.
We can apply,
Yes,
but
sir.
not
Yes,
yet
yes.
applied, right?
Not
yet
yet
applied.
applied, sir.
It's a
Yes, sir.
theoretical study only. Okay.
Yes, sir.
Yeah. Okay. Okay. Thank
Yes,
you.
sir. Thank you, sir.
The next speaker is Mr. 9NP Woman, and his topic. Okay. Okay. His topic is the designing of single sampling plan by attributes. Yeah, good afternoon. ఇక్కడ కావాలన్నా Yeah, last 1 minute, please. Hello. Yeah, am I audible? Okay. Looks like yeah. Thank you, Mr. Mr. Ninan and Ajarathan. Yeah. Okay. Any questions from the other participants? Any questions? Okay, we'll go to the next topic. Yeah. Next presenter, Mr. Ganapathy Swami. Acha, he didn't come. Okay. Acha, he didn't turn up. Mr. Ganapathy Swami and all. Okay, fine. Okay, then we'll come to the last presentation of the day. Okay, 1 minute. Yeah, Mr. Komaraju Kamal and G. Venkateshwar Rao. It's on the current challenges and current challenges of cyber forensics and remedial measures. Go ahead, Mr. Kamal. Yeah, you are from. Before that, you are from which institute? You are from which institute? You are from which institute? What is it? Geetam University. Okay, fine. Yeah. Yes, Mr. Kamal. Is it essentially a literature survey paper? You are planning to do some work in this area in future? Okay. Okay. You are a scholar from GITM University. What's your research topic on? Okay, fine. Thank you. Yeah. Okay. So well, with that we had a great session with the 2 invited topics, really thought-provoking, and then 9 presenters. 2 presenters didn't turn up, and we have excellent sessions. Okay. Overall, any other questions? Anything left out, Lavanya? Okay. So thanks to one and all. Thanks to all the participants. Thanks to the both the invited speakers. Thanks to Lavanya, to you also, and many thanks to Tirupati Rao garu and Abhinaswam garu. Okay, thank you very much. Okay. Yeah. I'm also from this university only. Okay, thank you. The meeting.
Very
Good afternoon, sir. Good afternoon, sir. Good afternoon, sir. Am I audible? Sir, are you able? Is it visible, sir? Yes. Good afternoon, sir. I'm Vamsi Priya, presently working as a lecturer in Statistics Department, Sri Kashyap Degree College. And with the guidance of Professor K. Nirupama Devi and Professor K. Srinivas Rao, sir, we have developed a non-stationary 2-tandem queuing model with direct non-homogeneous compound Poisson arrivals queues having intermediate departures. A queuing model is a mathematical model representing a queuing system. A queuing system will consist of arriving of customers, waiting lines, servers, and departing customers. The applications of queuing model are communication networks, cargo handling, banks, and reservation centers. And we have collected a few literature relating to time-dependent tandem queuing model. And with the motivation, we have developed so-and-so model. And the objective of a model is to develop two-station non-stationary tandem queuing model with direct arrivals to both queues having intermediate departures, and to obtain the performance measures, and to study the effect of variation of parameters, and to compare the model with the existing models. And we have assumed that the incoming pattern follows non-homogeneous compound Poisson arrivals with mean composite arrival state for the first and the second queues, having bulk size distribution CK1 and CK2, and the service facilities at both the service stations follows non-homogeneous Poisson process with mean service rate to the first and the second queues. Queue discipline is first in, first out. Queue length is infinite, and the probability of customer leaving the system after the service completion from the first service station is rho, and joining the second service station is theta, which is equals to 1 minus rho. And we have represented a schematic diagram where lambda 1 of t is for the first arrival of the first queue, and lambda 2 of t is for the arrival of the second queue directly to the second service station, where theta is the arrival time and rho represents the inter-departures. And with the help of these difference differential equations, we have obtained a probability generating function. And we have defined certain characteristics basing on this probability generating function. We have also developed the numerical analysis of the model. And we have represented the graphs of all these models, where considering some time of parameters with an increasing process and the remaining parameters as constant process, we have developed these graphs. We have also done the sensitivity analysis of the model, and we have, by fixing up certain values, we found that the model reduces to certain of the existing models. We are keeping the second service arrivals to zeros. We assume that the model reduces to m by 1 queuing system with state dependent service model. And if lambda 1, lambda 1 to lambda 2, 1, lambda 2 to beta 1, beta 2 equal to 0, the model reduces to two node tandem Poisson queuing models. And we have also assumed that the model reduces to one service facility queuing model with non-homogeneous Poisson arrivals and state dependent service. Keeping few other parameters equal to 0, we assume that it reduces to two node tandem queuing model with non-homogeneous arrivals and state dependent service. And putting on lambda 1 2 equal to 0, lambda 2 1 equal to 0, and alpha 2 beta 2 and rho equal to 0, we assume that the model reduces to single node Poisson arrivals, non-homogeneous Poisson service queuing model. And all these models are tested, and we have concluded that the developed queuing model with the assumption that Poisson arrivals follow non-homogeneous compound Poisson process, and the service process follows non-homogeneous service process having low dependent service rates with different traffic flows. And the assumption of non-homogeneous arrival and service process significantly influences the performance measures. And the inter-departures reduces the delay in transmission and the burst needles of the buffers. The direct arrivals to second queue reduces the congestion of the buffer in the first queue. And the strategy of low dependent service reduces the congestion in the queues and effectively utilizes the service. Thank you, sir. It is yes, sir. It is theoretical application, sir. Yes. Thank you, sir.
Yes, sir. Hello, sir. Yes, sir. Yes, sir. Sir, can I present now? No, sir. I am the next participant. Next participant means Pallavi Medhi. Yes, yes. I am ready, sir. Yes, sir. Is it visible? Yes, yes, yes. Is it visible now? Okay, okay. I think it is visible now. Okay, okay. Okay, okay, sir. Okay, so okay, sir. Okay, no problem. Okay, so, the respected chairpersons of this session, so respected other members, myself, Dr. Pallavi Medhi, Assistant Professor from the Department of Statistics, Guwahati University, and the title of my paper is Analyzing Impatience in Multi-Server Markovian Queue with Discouraged Arrival and Retention Strategy. So as you all know, we have to face the problem of queue in our day-to-day life, and in the current scenario of our world, people do not want to wait much more for service, and that causes definitely a negative thought on the behavior of customers. If it is required to wait, customers get impatient. So from that concept, the concept of queuing theory developed, and it had its origin in 1908 when Erlang published his fundamental paper on telephone traffic. And since then, various models have been analyzed considering various characteristics. One of such characteristics is customer's impatience. So in queuing parlance, the customer impatience can be reflected through balking and reneging. So now what is balking? Suppose a customer arrives into a system and he finds that the queue is too long, so he leaves the system without joining the queue. That is known as balking. And what is reneging? Reneging means suppose a customer arrives into a system and he joins the queue, and after some time he lost his patience and he leaves the queue. That is known as reneging. So these are some recent development in the field of customer impatience, customer retention, working vacation policy, and balking, reverse balking, etc. So the objective of this paper is actually in some established work. It is already established that a customer can be convinced to stay for his service by introducing certain types of incentives. So therefore, the retention strategies are therefore an important aspect in this direction. And at the same time, state-dependent arrival is also can be observed in our day-to-day life. One of the common form of type of arrival is discouraged arrival. And nevertheless, in today's economic scenario, corporate sectors are continuously trying to motivate the impatient customers so that the lost customers can be retained. So besides this, the reneging of type, RBOS, that is reneging till beginning of service, finds reneging till end of service finds little mention. And explicit close from expressions are also not available for this model, considering these assumptions. So therefore, our prime objective is to obtain the close from expressions of various performance measures of a multi-server Markovian queue with the considered assumptions. Now, the assumptions of the model, as I have already mentioned, that I have considered an MMC queue. So the arrival pattern follows exponential distribution with parameter lambda. Service pattern follows exponential distribution with parameter mu. There are only C servers where each server works independently. Balking probability is considered as state dependent, where and it is considered as 1 minus gamma to the power n minus C plus 1. Discouraged arrival is also state dependent, which is considered as lambda by n plus 1. And the reneging rate is considered as exponential distribution with parameter nu. And additionally, we have assumed that the retention probability as q, and the reneged customers may leave the queue with probability p. And then in the next section, we have derived the steady state probabilities under RBOS, and the equations are given in equation 1, 2, 3, and 4, where Pn denotes the probability that there are n number of customers in the system. We have also derived the probability that n number of customers in the system under RBOS, and it is defined in equation 5, where the probability that the server is in idle condition is defined in equation 6. Similarly, we have derived the steady state probabilities under RUS, and probability that n number of customers under RUS given in equation 11, and the server is in idle condition is under RUS is given in equation 12. And in a multi-server queue, it is very important that the queue starts from when the system state reach C. So it is very much important to define the probability that a probability of n greater than equal to C, and that is denoted by ZRBUS under RBUS and GRUS under RUS. And in the next section, we have derived the closed form expression of the various performance measures. So mean system size and mean queue size under RBOS are given in equation 13 and 14. Under RUS, these are defined in equation 15 and 16. Then effective arrival rate is defined in equation 17 and 18. And average reneging rate under RBOS and RUS is given in equation 19 and 20. And the most important part, the loss analysis, the average loss rate under RBOS is given in equation 21, and under RUS it is given in equation 22. And from these two closed form expressions, we can easily calculate the proportion of customer lost and proportion of total completion of service. And then the actual load of the server under RBOS is defined in equation 25, and under RUS it is defined in equation 26. Then to illustrate the use of our derived result, we put them to a queuing scenario. We quote below an example from Ellen. So here the customers arrive at the Kitten House, the local house of questionable services, at an average rate of 5 per hour, and service rate is 20 minutes per customer. So the owner of the Kitten House actually want to know that the minimum number of servers she should provide, so that the probability that an arriving customer must wait for service will not exceed 0.25. So this is definitely a design problem where the arrival rate is 5 per hour and the service rate is 3 per hour. And we have to verify the minimum number of servers we should appoint considering all the assumptions. So it is definitely, even if it is not clearly mentioned about yes, sir. Reneging and bulking. So we have to assume that. So we have considered two scenarios. We're considering reneging rate is 0.5 and another is reneging rate is 1. And from these two scenarios, we can obtain that the ideal choice of the number of server is C. So the owner of the Kitten House can run his business with one additional server. Then we have performed the sensitivity analysis theoretically as well as numerically with variation in lambda, mu, and nu. And then the conclusion part. So this paper presents a stochastic modeling of MMC queuing model under the assumption of discouraged arrival, state-dependent bulking, and retention of reneging. And even though bulking and reneging have been discussed by others, explicit expressions under the assumption of discouraged arrival and retention of reneging are not available for this model. So this paper makes a contribution here. Additionally, the closed form expressions are presented for both traditional and novel performance measures, and the derived results are validated with the help of a numerical example. The numerical example is of indicative nature, meant to illustrate the benefits of our theoretical results in a design context. And the limitation of this work is that considering general distribution, also the model can be extended in a non-Markovian setup. Also, the same model can be analyzed in transient state. So these are my references. Thank you. So I want to thank all the organizers for giving me the opportunity to present my paper, present my research work in this international conference. Thank you, sir. Thank you, sir.
Am I audible, sir? Okay, fine. Is my PPT visible, sir? Okay, thank you, sir. Okay. Good afternoon, everyone. This is Gyandeep Sharma. Today I'm going to present my research work on analysis of customer impatience in single server Markovian queuing model by myself, Gyandeep Sharma, research scholar at Guwahati University, and my supervisor, Dr. Pallavi Medhi, Department of Statistics, Guwahati University. Okay, Tom, let's. Okay, sir. Okay. Okay. Introduction. Queues are a common phenomena in our life. It usually formed when customers don't get immediate service. That is, demand for some service facility goes beyond the capacity of the facility. As customer has to wait, this induces impatience in customer. Mainly two types of impatient behavior of customer is seen: bulking and reneging. Bulking a customer is said to be bulk if customer decide not to join the queue upon the arrival to the queuing system. Bulking can be divided into two types, mainly state independent bulking and state dependent bulking. Reneging. A customer is said to be reneged if arriving customer joins the queue but after some time leaves the queuing system without completely receiving the service. Reneging can be split into two types, namely till beginning of service, in short RBOS, and reneging till end of the service, in short REOS. This is my literature review. Objective. It is clear that the stochastic modeling of single server Markovian queue under both reneging rules considered state dependent bulking is not available. So it becomes very important for any management to have some proper expression in order to have an idea of the possible business lost. So the objective of this paper is to derive close form expression of various performance measures for single server queuing model under the assumption that customer can bulk as well as renege. Model assumption, these are my assumption. The arrival rate is assumed to follow Poisson law with parameter alpha, Poisson law with service rate with beta, reneging rate gamma, bulking probability as 1 minus theta to the power n, service discipline is FCFS. There is only one server and the system capacity is infinite. Steady state probability, to obtain the steady state probability we use the Markov method, and n is assumed to be the state of the system. This is the transition diagram for RBOS. These are my steady state equation where xi n denote the n probability of n customer in the system, in the queuing system. On solving those equations recursively, we obtain the following steady state probabilities: xi n, and using the normalizing condition, that means total probability condition, we obtain the value of xi naught. Similarly, we have the diagram for state transition diagram for RUS, which is given here, and the steady state equation are given. These are the steady state probabilities. Performance measure. Mean here the expression for mean system size and mean queue size are given for under RBOS. Similarly for RUS, these are also here. Mean waiting time in the system for RBOS, these are obtained using Little's law and the expression are given. For RUS, we have the following expression. Effective arrival rate, as we know, all customers who arrive to the queuing system will not join the queue because of bulking. So the effective arrival rate expression, we have the following effective arrival rate expression for RBOS and RUS. Management would also like to know how many customers renege on an average. So the expression for average reneging rate under RBOS and RUS are given here with. Management would also like to know what is the business loss for them. So that measure is obtained using the mean rate of customer loss, and the expression are for both the reneging rules are given here. Next is the proportion of customer loss. Both the expression for RBOS and RUS are given here. Actual server load, as we know that all the customers who join the queue, many of them will renege. So the load, that means the work the server has to do would be different from what actually was assumed. So the actual server load expression are given here. Numerical example to illustrate the usefulness of derived result, we use the following example from Ravindran Philip and Solver book, published in 1987 in page number 338. The problem is like this, that wheat is cultivated in a field. During harvest season, wheat is harvested and loaded in truck, which is then transported to town. Before getting the truck to be checked in where the truck was weighted, a sample of harvested crop from the truck are taken for various tests. Now the trucks arrive to the facility at the rate of 9 per hour, and check-in process takes 10 check-in process rate is 10 per hour. Now, given the nature of the problem, it is natural that there will be bulking as well as renaging. So we have assumed the renaging rate to be 2 per hour and consider two bulking probabilities, 0.1 and 0.5. Now, using these parameters, we have computed various performance measure using Python program, and the results are given here in the table. Now, from the table, we see that only the proportion of customer loss due to bulking, this only increases, but the rest of the performance measure, these are all those values all decreases. Sensitivity analysis. This analysis mainly performed when the parameters changes and the effectives studied for Zinode and eta nodes. So here are the here is the sensitivity analysis. As alpha increases, this Zinode decreases. Beta and gamma increases, Zinode also goes increases. But okay, sir, only few slides, sir. Okay. Next is effect of performance measure on varying alpha. From the graph, we see that as arrival rate increases, all the performance measure goes up, and all the performance goes up. Now, effect of performance measure on for varying beta. When my service rate increases, then what is the effect on other performance measure? Now, as we can see, as beta increases, actual server load increases, because if we increase the service rate, the server will have to do more work. But as beta increases, rest of the performance measure, this will go down, and the effective arrival rate will have no effect on service rate. Similarly, for varying gamma, as renaging rate increases, average renaging rate will go up, but rest of the rest is given here. Conclusion: we have given a complete mathematical analysis of MM1 queuing model considering both renaging and state dependent bulking. A numerical example is also being discussed to demonstrate the usefulness of the derived result. This paper can be extended in numerous ways. One way would be including the cost consideration of the modeling. The derived result can also be extended considering general distribution. These are the references. Thank you for giving me the opportunity to present my work. Thank you. Thank you, sir.
Yes, sir. ఎలా షేర్ చేయాలి? Sir, I'm sharing the PPT, sir. Sir, am I audible, sir? Okay, sir. Okay, sir. Yeah, wait. ఫైల్ లేదు. మ్యామ్ చేస్తున్నాను. అది అవ్వట్లేదు మ్యామ్, చేస్తున్నాను. ఓకే సార్, ఓకే. Sir, I presented. Sir, 1 minute, sir. Oh, okay, sir. Now it visible, sir. Good morning, sir. Good morning, everybody. Good afternoon. And my today's my topic is unparalleled queuing series and queuing models with non-stationary service process having a state-dependent service rates. This is my title of this today's paper. So many queuing theory had the origin of 1919 when the Organ, Kassep and Langian. The queuing theory is related to the study of telephone traffic and intelligence of the transportation systems and telecommunication networks and traffic flow. So this is the main origin of the queuing theory. And that's the next one, my queuing theory models. The queue is a waiting line of the units demanding for service and service facilities. Queuing model is a mathematical model representing to the queuing system. And queuing system is consisting of a customer arriving to the service and waiting for service and leaving for the system after the being to be served. It is nothing but interconnectivity of the process is called as the queuing system. The customer, the unit demand service is called as a customer, and server, the device which is provided to the service to the customer is called as a server. The queuing system is consisting of processes, namely arrival to the customer, arrival, and number of the servers completions. The service process is nothing but a service process. My queuing theory process is based on that MM1 model. And applicable and where queuing models are, we applied various areas like communication networks. In communication networks, the packets delay of the bursters of the communication system, and in transportation systems like air, road, and shipping. In these areas, we apply to the queuing models and production process, ATM scheduling, and reservation systems, banks, hospitals, and claiming settlements. In these areas, these are the major applications of the queuing system. The different types of queuing models are the systems with correlated arrivals, the system with correlated service times, the systems with state-dependent service rates, and systems with state-dependent service rates, the system with interdependent arrivals and service process. So the main objective of my paper is we connected parallelly and series tandem queuing models with a state and time dependent service rates. So in this paper, we have two queues are connected parallelly and series, and after that, completing the service of the first two parallel, and after the connectivity of which is randomly connected to the third queue, we enter to the person to third queue. So this is the main objective of this model. So the types of queuing model is, so in this paper we have in this paper we derive the joint probability distribution function of the queue size of P queues derived, and after that the system performance measures such as the average number of customers in each queue, the average waiting time of the customers in each queue, and throughput of the service station, utility of the service station, and variances of this connected with the queuing model are derived. The sensitivity analysis of the numerical illustrations related to the time and state dependent service rates having a significant influence of the system performance measures. During the last 12 decades, much work have been reported regarding the queuing models and to their utility of scheduled network transportation systems, cargo handling, and manufacturing utilities. Recently, the load-dependent service models are having gained a lot of importance and utility of the utilizations. These are Suresh Verma. These are derived to the state-dependent service rates with non-homogeneous service processes. And in these papers, this is the next. However, these papers are eligible to the service process homogeneous independent of time. As a result of inter-service time follows the exponential distribution. The reality of some special situations different from the homogeneous service process is exponentially inter-arrival times. Because of the service, several constructions of the condition service process, the utilization of the server may be efficiently and effectively. Okay, sir. The performance measures. The main queuing model, we assume that here we are applying the arrival parameters. The Poisson arrival rates are lambda1 and first queue, and lambda2 is the second queue. After that, the main assumptions of the service follows non-homogeneous Poisson process. The service rates are we have taken mu1 of t and mu2 of t and mu3 of t. These are the linear equation formations. The second and formations, and after that, this is the schematic representations of my model. The lambda1 is the number of arrivals to the customers. N1 is the number of customers arrived to the first queue, and the service process is the mu1 of t. The service rate is mu1 of t. This is queue, and the second queue is the n2 number of customers arrived to the lambda2, and the service parameter is lambda mu2 of 3. And these we get these two queues are arranged to the parallel, and after getting the service, the person entered to the third server, that is arranged to the series model, that is n number of customers is entered to the service mu3 of 3. And after the completing these three processes, they from mu3 server. So these are all my differential equations, and we are applying Lagrange's method and derive to these parameters, and we get the probability generating function. The probability generating functions, we first and second, third queues are we derive, and after that these probability generating function, we are deriving the characteristics of the probability generating function of the first queue and second queue, third queue, and mean number of customers to the first queue and second queue, third queue, and utilizations of the service station, throughput of the service station, and main of these three queues. So based on that, throughput is a very important parameter by servicing provider to have effective and efficient utilizations. These are the utilizations of the service parameters and the mean rate variances. So after completion of the derivation part of the numerical illustration and sensitivity analysis, and these based on that, these derivations we derive we increasing the time parameter values increasingly, and after that what happened to the what happened to the mean arrivals and a probability of emptiness of the queues. And these are the graphical representations of the performance measures and parameters. And here the time is increases. When the time is increases, the utilizations of the decreases in first queue and third queues are third and second and third queues respectively increases. So based on that, the third, these are the variances of the difference parameters. And this is the graphical representations of the mean values and irrespective of the time parameters. After that, we have to derive the sensitivity analysis and comparative analysis is also. So I said conclusions. I concluded. So in this paper, we design and develop the novel and time and state dependent service process having a parallel and series tandem queues. In this model is very useful to analyze the communication networks such as LAN, WAN, MAN, data-wise transmissions and other transformations during the peak hours. Here the service process is categorized in non-homogeneous Poisson services. In observe the time and state dependent service processes has a significant influence in the system performance measures. It's also possible to extend this paper non-homogeneous arrivals also, sir. So these are my references. Thank you, sir. So welcome, sir.
Yes, sir. Good afternoon, everyone. My present on the topic. Okay, sir. Sir, is it visible, sir? Okay, sir. And the topic is one server queuing model with tuned arrivals having non-homogeneous Poisson service process with load dependent service. Under the Professor K. Srinivas Rao, sir, Research Director, Department of Statistics, Andhra University. Introduction.
A waiting line of units for service at facility forms queue. Queuing model characterizes the waiting time. The importance of queuing model systems like transportation system, communication system, machine repairing, etc. And the application of queuing are production process, cargo handling, inventory control, and hospital management. And some of the reviews, all these authors are developed various queuing models. Arrivals refers to anything that arrives at facility and requires a service. Server refers to anything that provides the requested service. The load-dependent queuing models, it is common to consider that the arrival and service processes are uniform and time-dependent. In all these models, utilizing the transporting equation and the time-related behavior of the model analyzed by obtaining the joint probability generating function for the queue size. The system measures of performance like probability. All these characteristics are derived. The load-dependent service rates can reduce the congestion queues and delay in service. And analyze a queuing model in which arrival process follows a Dune process. In Dune process, the entire arrival time follows Weibull distribution and the mean arrival rate is a function of time. It is assumed that service process of the system is also non-stationary and follows non-homogeneous Poisson process. It is also pre-assumed that the service rate depends on the queue size connected to it. And the assumptions of the model, the arrival process is pre-assumed to be Dune process having the parameter lambda of t, which for this process is represented by non-homogeneous Poisson process with the parameter that the service rate is a dependent number of customers in the queue. The queue discipline is in first in, fast out. The queue capacity is infinite, and the schematic diagram is as follows: arrival, queue, and the service, server, and departure. Methodology: let n be the queue size and the P1 of t is the probability that n customers are arriving the queue at a time t. Using different differential equations, the PGF is derived is as follows. On solving these equations, we get a probability generating function. Consider the service rate as a linear and time dependent as a parameter mu of t. For solving the first and second equations, we get the parameters a and b. Using the initial conditions of p naught of 0 equals to 1 to 0, we get a probability generating function Ps of t. The characteristics of the queuing model, the emptiness of the probability, expected value, and stationary service station utilization, and the variance of the system size. The numerical illustration of the model is as follows. And the analysis part of the table is as from the table, as the time increases, the characteristics are increasing, whereas rate of value is decreasing. As the arrival parameter A increases, the characteristics are increasing and remaining are decreasing. As the arrival parameter B increases, probability and coefficient of variation decreasing, remaining are the increasing. Conclusion: this chapter deals with the non-stationary queuing model. Here, the arrival process is characterized by Dune process. In Dune process, the inter-arrival time follows Weibull distribution. The Dune process also includes a Poisson process, non-homogeneous Poisson process, and particular process. The Dune arrival process also includes the mean arrival rate is constant, increasing or decreasing as per the index parameter. The service process is characterized by non-homogeneous Poisson process, which includes Poisson process particular cases. The service rate is load dependent as well as time. And it is also observed that load dependent service rate can reduce the delay in transmission and vastness of buffers. It is also possible to extend of this model to multi-node communication networks, which will be taken up as rare. Thank you. Thank you, sir.
Yes, sir.
Thank you. Good afternoon, sir. Am I am I audible, sir?
Your voice is very feeble, and we are not able to hear you.
Good afternoon, sir. Am I audible, sir? Because give chance to this talk. This is my name is Nirupam Sahu from Government University. That is helpful from Odisha. Visit all of you. My topic is your system and that sets actually this is the know that the link to collect observations from a population that would like to span that values in the population. Then them observation is obtained by full sampling. So it is rank sampling and objective to random sampling. Here we will estimate yes, sir. Just two words, sir. That is. Yes, yes, sir. So here we have to define what is rank set sample and how to collect it. This follows first the initial simple random sampling of k units is selected from the population, and we have that order, the rank order on that attribute of units, and the can be used to obtain that string that is that is comparison export opinion, that how we get this ranking procedure, and basically this ranking is our attribute, or that is our characteristic. So export opinion through the use of auxiliary variables, but it is one of the that is cannot involve actual measurements because it is an attribute of or qualitative in nature. So here we have that include the unit which just place in the rank is included the first item in the rank set sampling, and the attribute of interest is formally measured for that unit. The initial measurement is called the first judgment, and it is denoted as by x1, and where this is x1, I have taken that square bracket, it is order statistic, and instead of this round bracket I have taken this square bracket, it is an order statistic, and this is smallest order statistic, and this x1 and may or may not actually have the smallest attribute measurement among the k units the simple random sampling, even though our ranking just it to be the smallest. Following the of this one, and then we have to next proceed second that is simple random sampling. And to do that, it is a sampling method where units are selected from population that has equal and independent chance being included in the sample. So in this process, this is dependent of first simple random sampling. So this first at x1 and next this is x2. Out of this that k unit, so that is selected from the population, and in the same manner we have to process in second, third, and like up to that kth order. So from the second, that select the item rank as second smallest unit and x2, and which is denoted as x2, and from third it is x3, and this process continues until we have selected it the unit k and include that as k. Is now reaction
కాదు
and it called
గూగుల్ మీట్ నాకు ఏ రాలేదు, నాకు ఫార్వర్డ్ చేస్తావా? ఫార్వర్డ్ చేయి.
number of units k, each simple random sampling is called the set of sets, and to complete a single rank set cycle, we need to that k square unit for and random samples of k each, and the measured observations to up to xk. This side k. This is the descriptor who that is that or study for the bank to bank one cycle to cycle one two three up to cycle. Now, we you know that include some and that
Excuse me, ma'am.
So, my
Your voice is breaking and your slide was not visible, ma'am.
not
Slide was
yes,
not. Voice is
yes.
also breaking, ma'am. Slide is also not visible.
Now my slide is visible.
No, ma'am.
Just wait, sir. Stop. Come on. Yes, yes. Yes. Slide is visible. Is basically rank set sampling, and this is balanced rank set sampling of size and this and sampling the same of size in a number of important ways. But this simple as that simple random sampling, it is basically done so that observations are usually independent. As we know, this is simple sampling select in the process has equal independent chance of being included in that sample. So here, so when say probably speaking, that means that each of the individual samples represent significant value present from the underlying population. So that is not the case for sample of sample. While the individual observations in balanced rank sample mutually independent, clearly not identically distributed. So that individual observation, that is the situation where we take that simple sampling process. Right? We have to select that to the rank set sample. So that observation in a set sampling do not repeat the typical values from the underlying population. So in individual judgment of statistics present very distinctly different portions of the underlying population. So this is a very important feature of unranked set sample as the items in this sample are designed in such a way as to provide greater assurance that the entire range of the population values are represented. Now, basically the concept of rank set sampling was given by McIntyre 1952, and in order to estimate the population means of pasture and forest yields. So he claimed that rank set sampling was more accurate than simple random sampling, and it is an alternative method to simple random sampling. So when quantification of sampling units is either costly or difficult, in that is in the simple random sampling, what you do, that is, even if that process is that is the process, but tracking the units it in a small set is very easy and inexpensive. So in such a situation, we can use that rank set sampling. So now this is for the notations used in rank set sampling, and here the one of the that is one of the estimator proposed, where this is followed by motivated by the Khan and Sabir 2016 paper. And here also I have taken one of the other process, simulation. As we know that simulation, it is that is the imitation of the operation of real world process or system over time. So this it is a model construct or conceptual framework describe a system. So this is the simulation of model can be used that to investigate a wide variety of what if questions about real system. So here I have taken that simulation process followed by that is our Khan and Sabir that paper, and here I have shown that is our proposed estimator is more efficient in comparison to other existing and also Khan and Sabir estimator. Now these are the notations, these rank set sampling, and that is, so these are the list of existing estimator, that is that Mutlaq paper, and here I have taken the comparison of 5 estimators, including that Sabir and Khan paper. These are the notations for this. Now see that Khan and Sabir proposed a class of estimator of the population mean under this rank set sampling. This is that A, B, and that G, and that all are that is our constant parts. And this is my estimator, that is y bar RSS under this, that is our ratio estimation method, and by using that exponential technique. Now this is the one of the situation here we have considered 2 cases. That is case 1, I've taken K1 plus K2, that is our up to K size is K1 plus K2, that is equal to 1, and that K1 optimum I have got. And second case, in K1 plus K2 is equal to 1 case, I have got one of the mean square error under this optimum case. In case 2, second case is K1 plus K2 is not equal to 1, and that is 2 optimum cases, K1 optimum and K2 optimum. In this case, that mean square that is minimum case, it is found. To carry out that study, I have taken that population already. This is included in where it's now more of latitude. So this is the our regarding this. Now we set here R is equal to 10 and M is equal to M5 to select a sample N is equal to MR. That is okay, here the size of that is cycle. Now the population of size A, 3059. So in this study we have the value of W where WX is, see this is the earlier defined this case. This is also simulated by that 7 that is means Sabir paper. This is the notational of WY square and WX square. Look at this. This is the person that is the relative efficiency of first class of estimator lesson study. So all the estimators, including our estimator also here, that is in case 1 and case 2, R06 and R07, it is our estimator, where this is 2 cases where K1 plus is equal to 1 and K1 plus K2 is not equal to 1. Here we have got 2 cases, and this is percent relative efficiency. So in comparison, what is so, that is a comparison to these 5 estimators, that is my estimator is gives more efficiency. So that is our case simulation study. Yes. Yes, sir. Yes. So this is the graphical presentation of this percent relative efficiency. Now here this percent relative efficiency of this proposed as well as existing have been compared, and here we have considered this is for that in graphical presentation what you have done. This is written in this form. Now finally what we got, that is the proposed class of estimator is more efficient than existing estimator. And when what is this condition? 165.4 to 70.18, the alpha value changes from 2.1 to 0.9. This is one of the situation in simulation study we got, that is the value that is our increases 165 to 170, and within the alpha range is 0.1 to 0.9, and this side that alpha close to 0.5. So that so the case 2 is more efficient than the case 1. Yes, sir. Any queries? Yes, sir. Yes, it is already. It is already completed, sir. Thank you, sir. May I quit, sir? Okay, sir.
Ma'am? Yes, ma'am. Yes, ma'am. Shall I start, ma'am? Okay, ma'am. Good evening to another present here. I am M. Priyadarshini, research scholar, doing my research under the guidance of Dr. D. Jayanti Madam, Assistant Professor, Department of Mathematics, Arunachalingam Institute for Home Science and Higher Education. Today, the topic of my presentation is operators of cubic intuitionistic fuzzy set. I had divided my presentation into 5 parts, including introduction, preliminaries, operations of cubic intuitionistic fuzzy set, and their references. The first formal study of these sets were introduced by the German mathematician George Cantor. Fuzzy set is an extension of a classical set introduced by Zarde in 1965. Zarde developed the idea of interval-valued fuzzy set as an extension of fuzzy set in 1975. The generalization of a fuzzy set known as an intuitionistic fuzzy set, which includes a degree of membership and a degree of non-membership, were introduced by Atansov in 1986. Interval-valued intuitionistic fuzzy sets were first described by Atansov and Garkov in 1989. The cubic sets were introduced by June, Kim, and Yang in 2012, which combines the interval-valued fuzzy sets with the fuzzy sets. Cubic intuitionistic fuzzy sets were first developed in 2018 by Gahandeep Karur and Harish Garg. They discussed the concepts of p-order and r-order in cubic intuitionistic fuzzy sets, as well as the operations p and r union, p and r intersection, p and r addition, and p and r. Also introduced the classification of intuitionistic fuzzy sets as internal and external cubic intuitionistic fuzzy set. Here I mentioned some basic definitions like intuitionistic fuzzy set, interval-valued intuitionistic fuzzy set, and cubic set. Cubic intuitionistic fuzzy set is a combination of an interval-valued intuitionistic fuzzy set and an intuitionistic fuzzy set. And it is denoted by script A equal to A comma lambda, where A is an interval-valued intuitionistic fuzzy set and lambda is an intuitionistic fuzzy set. Among the basic operations which can be performed on cubic intuitionistic fuzzy sets are mentioned here. Two types of cubic intuitionistic fuzzy sets are defined. If intuitionistic fuzzy set belong to interval-valued intuitionistic fuzzy sets, then it is called an internal cubic intuitionistic fuzzy set. Otherwise, it is called an external cubic intuitionistic fuzzy set. Gahandeep Karur and Harish Garg introduced the basic operators such as union, intersection, addition, multiplication, exponential, and a p order. Following that, I will show we define some new operators on cubic intuitionistic fuzzy set under p order. Let capital X be a non-empty set and script A and script B be two cubic intuitionistic fuzzy set in X. We define the following operations on script A and script B: A at B, A hash B, A dollar B, and A star B. We define over the set of all cubic intuitionistic fuzzy sets two operators which will transform every cubic intuitionistic fuzzy set into an cubic fuzzy set. These two operators, like the operators of necessity and possibility defined in some model logics. Some of the properties of above operators are also described and analyzed. We try to define some more new operators on cubic intuitionistic fuzzy sets, such as P concentration, P dilation, and P contrast intensification. A linguistic hedges is an operator or modifier that acts on the membership function to modify its shape and hence its primary meaning to the secondary linguistic meaning. It is classified into two categories, type 1 and type 2. In type 1, the edges can be approximated by an operator acting on a single fuzzy set. In type 2, the effect of the edge is more complicated, requiring a description of the manner in which the components are modified. P contrast in P concentration, it reduces the degree of membership and degree of non-membership of the values by squaring each member in the set. So P concentration equal to A square. P dilation. The effect of dilation is the opposite of the concentration. It expands the degree of the membership and non-membership values by taking the square root of each element. So P dilation equal to A square, A power 2. The contrast intensification, as its name implies, reduces the fuzziness of A by increasing those of membership values which are above 0.5 and decreasing those of which are below it. So, P contrast intensification equal to 2A square. The properties of P concentration, P Ma'am, these operators are used to in image processing problems, ma'am. Ma'am, image processing problems, ma'am. Please. Thank you, ma'am. Thank you, ma'am.
Ma'am, yes, ma'am. Good afternoon, ma'am. Okay, ma'am. Yes, ma'am. Ma'am, is my screen visible? Ma'am, is my screen visible now, ma'am? Ma'am, is now my screen? Okay, ma'am. Good afternoon, ma'am, and good afternoon, everyone. I, K. Vasvi, research scholar from Applied Mathematics Department, with the guidance of Dr. T. Vinuta. Today, my topic is the study of anisotropic spacetime in exponential gravity. The main outlet of this work is introduction, metric and field equations, cosmological parameters, conclusions. The alternative theories in the present day achieved huge success as they can explain the behavior of dark energy and cosmos expansion. Some of these is based on modified theories of gravity. The modified theories have chosen interesting among the alternative theories which can explain the accelerating expansion of cosmos and the concept of dark energy. The queries which are not solved in general relativity were addressed in these modified theories, as general relativity cannot describe the expansion of cosmos without the interference of few terms in the Lagrangian. The alternative theories in the present day achieved huge success as these can explain the behavior of dark energy and cosmos expansion. Sorry. The queries which are not solved in general relativity were explained in these modified theories of gravity. Moreover, the modified theories of gravity has assumed to be purely geometric in nature and are simple geometrical extensions of general relativity. These theories introduce the unknown fluid substances like dark matter and dark energy in the universe. Similarly, the problems related to ultraviolet and infrared scales are studied in these modified gravities
to describe various reasons in the accelerating expansion of the cosmos. In the study of cosmos evolution, the FR theory of gravity is very helpful. And this FR theory of gravity has become familiar by replacing the matter Lagrangian through an arbitrary function in the action principle of Einstein-Hilbert. This FR gravity is first proposed by Hans and Wissel in 1970. This FR gravity is known as families of theories, as each one is identified by a different function of Ricci scalar, which is represented by R. Later on, followed by the works of Starobinsky, it has become an active field of research. Okay, ma'am. Okay. Later on, this FR theory is generalized to FRT theory by the works of Harco and his collaborators. The main outstanding results provided by this FR gravity in various fields are dark matter, dark energy, wormholes, density fluctuations, gravitational waves, and so on. In this work, we have considered the anisotropic axially symmetric, which is presented in the equation 1. Here, M and R metric potentials, which are functions of time, and the coordinates xi, phi, z are called the FRT gravity field equation 2 is represented in the equation 2. And in this work, the functional form of FRT is considered as R plus M exponential minus NR plus lambda t. And the field equations of our work is represented in the equations 3, 4, and 5. These are 3 field equations containing 4 unknowns, namely M, N, P, rho, and R, where M and R are the metric potentials, P, rho are the pressure and energy density of our model, and R is the Ricci scalar. In order to solve these unknowns, we have assumed 2 physically valid conditions, and first one is given in equation 6, which is known as hybrid expansion law. And second one is the relation between metric potentials assumed by the relation sigma is proportional to theta. Here sigma is the shear scalar and theta is the expansion scalar. Using these 2 conditions, we can obtain the values of M and N, which are represented in this. And now coming to cosmological parameters of our model. The main cosmological parameters described in our model are pressure, energy density, dissolution parameter, volume, Hubble parameter, expansion scalar, jerk parameter, and state finder parameter. And equation 8 is the expression for pressure. In FRT, the pressure and energy density are considered to be important tools and even for illustrating the behavior of dark matter and dark energy. And equation 8 is represented for pressure. Equation 9 is the equation for energy density. And this is the graphical representation of pressure corresponding to redshift. And from this figure, we can observe that the pressure completely lies in the negative region, which indicates the accelerating expansion of the universe. And this figure represents the plot of energy density corresponding to redshift. And from this figure, it is observed that the energy density completely lies in positive region, which also describes our universe is in accelerating expansion. And coming to next cosmological parameter, dissolution parameter. Using this dissolution parameter, we can describe whether the universe is accelerating or decelerating. It is represented with Q, and which is given as minus A double dot by A dot square. Here A is the scale factor, and if Q value is greater than 0, we can describe the model is in decelerating phase. If Q value lies in between -1 to 0, we can say that our model is in accelerating phase. And for Q equal to 0, we can observe the behavior is stable. And for Q equal to -1 and Q less than -1, we can say that there is an exponential and super exponential expansion. And equation 10 represents the value of Q for our present model. And this is the graphical representation of dissolution parameter corresponding to redshift. And from this figure, we can observe that for all the values of Z, the value of Q is less than 0, which indicates our model is in accelerating expansion of cosmos. And coming to next cosmological parameter, Hubble parameter and expansion parameter theta. These 2 parameters are represented graphically in the figures 4 and 5. Both the figures show that Hubble and expansion are positive for all the values of Z, which indicates our universe is in accelerating region. And next, coming to another cosmological parameter, volume, and this is the graphical representation of volume. Volume also completely is in positive region. And next, coming to energy conditions. In better understanding of the singularity theorem like black hole thermodynamics, the energy conditions plays a vital role. The basic energy conditions derived from Raychaudhuri equations, which are null energy condition, dominant energy condition, strong energy condition. By using these basic tools, the complete space-time structure can be predicted instead of finding the accurate solutions to Einstein equations, which plays a crucial role in understanding the interactions caused due to gravitational cosmology. And the graphical representation of strong energy condition corresponding to redshift is given in this figure. And for all values of Z, the strong energy condition is completely in negative region, which describes the model is in accelerating phase. And coming to dominant energy condition and null energy condition, which are represented in figures 8 and 9, dominant energy condition is satisfied and null energy condition is also satisfied. Coming to state finder parameter, using this state finder parameter, the cosmic acceleration, and to solve the fine-tuning issues, many dark energy models came into existence. To differentiate various dark energy models, the state finder parameter were proposed by Shani et al. Yes, ma'am. Yes, ma'am. These are my conclusions of my work. The pressure is negative and increasing function for both the values of eta, and coming to energy density, it is positive and decreasing for both the values of data, from which we can conclude that it is an accelerating expansion of cosmos. The deceleration parameter in our work lies in negative region, which also indicates the universe is in accelerating phase. The strong energy condition, dominant energy condition, null energy condition for both the values of eta is plotted in the figures as I have shown. This strong energy condition is violated throughout the expansion of cosmos, and the RS parameter shows it initially lies in the Champlegian gas region and later approaches the quintessence region by crossing the lambda-CDM model. The jerk parameter in our model lies completely in the positive region, which represents the lambda-CDM model. These are my conclusions and references of my work. Thank you. Thank you. Yes, ma'am. It becomes isotropic for eta equal to 1, ma'am. As we mentioned in this property, for eta not equal to 1, the model is anisotropy, and for eta equal to 1, the model attains isotropy form, ma'am. Thank you, ma'am. Thank you, ma'am.
Yes, ma'am. Myself, Madhubabu, working as a assistant professor in Rocky Engineering College. Presently, I am doing my part-time PhD in Geetham University under the guidance of N. Sridhar. Here, my present work is unique solution to the differential equations of fourth order with non-homogeneous boundary conditions. Here, my abstract is, here the purpose of this research paper is to provide the uniqueness of solution to fourth order linear differential equations with non-homogeneous boundary conditions using the sharper bounds of the integral of the kernel. The uniqueness of the solution to the problem is established based on Banach fixed point and Rux fixed point theorems on metric space. Here keywords are differential equation, 3-point non-homogeneous conditions, kernel, existence results, and fixed point theorems. In general introduction, the differential equation is an essential tool for understanding and interpreting various problems in scientific knowledge. Here, the idea that laws concerning these situations, differential equations of various orders under certain conditions. In general, the fourth order differential equations will arise in the modeling of viscoelastic electric circuits, theory of plate deflection, beams, and various areas of applied mathematics as well as engineering. In fact, the fourth order differential equations and model for bending of deformation of elastic beams. In 1988, Gupta established the existences for bending of elastic beam with complete support edges and is given by differential equation with boundary condition. Later in 2003, the differential equation with boundary conditions. Later in 2016, Lockwood and Zhengfei studied the existence, uniqueness, and paucity of solutions by various fixed point theorems. Again in 2019, S.S. Almutabiri and C.C. Dejdar proved sharper existence and uniqueness results for solution to third order boundary value problem. Again in 2021, R.R. Shankar, R. Ravishankar, N. Sridhar, and K. Rajendra Prasad considered existence results for fourth order non-homogeneous 3-point boundary conditions. Whereas some other researchers have more explored to study the existence and uniqueness of solutions to the boundary value problems of third order and fourth order. All papers, we have considered the fourth order differential equation with non-homogeneous boundary conditions under them, and the existence results are established using fixed point theorems on metrics. In real world applications and in interpretation of differential equation, the problem must be well posed with certain conditions, which means the problem must have a unique solution. It has certain identity conditions. If the problem is not well posed, which means if the problem has no solution or two or more solutions must be created in new model. Here, for the sake of our simplicity, the notations listed below are used and as C1, C2. Here, results of preparation. Here, we first derive the solution of problem 1, 2 by expressing into an equivalent integral equation involving kernel. And after that, the sharpness estimates of integral of kernel is computed. These are helpful in finding our major findings. Here, let psi of x be belongs to C, then the unique solution of the problem will be satisfying the conditions specified in 2. Theorem 2.1. Let delta not equal to 0, then the unique solution to the problem 3 and 2 is given by v of x. And where we, in v of x, we find h of this one, and it will be like, it will be assumed as 4, and m of x assumed as 5, and it is assumed as 6. Lemma 2.2. The kernel in equation 5, given in equation 5, is non-negative for all. The kernel given in equation satisfies the following integral inequality. The kernel given in equation 6 satisfies the following integral inequality. Here the kernel given in 4 satisfies the following integral inequality. Here theorem, here we use two matrices in accordance with Rush theorem and Banach fixed point theorem. Thus theorem 2.6 and 2.7. Main results based on matrix. The existence and uniqueness of solution to the problem 1, 2 are established based on matrix in this section. Let D be the set of real valued continuous functions and are defined on AB. For V, W belongs to D. Now we define the matrix of D as follows. Here the order pair D comma D forms a complete metric space where D row is a metric space but not a complete. The matrix D and row on capital D and is given by this. Let us consider the operator F where it is mentioned in 4. It is evident that V of x is a solution of 1 and 2 if and only if v of x satisfies the following condition, following inequality. Here, now we assume the following condition is true in the entire paper. Here, this E1 has with ellipses. We use two metrics in accordance with Rush theorem for establishing existence results uniqueness theorem 3.1. Suppose the condition E1 is fulfilled and if B minus A satisfies the following inequality, then there is a unique solution of the problem 1, 2. Suppose the condition, theorem 3.2, suppose the condition E1 is fulfilled if there are two positive numbers P greater than 1, Q greater than 1 and 1 by P plus 1 by Q equal to 1 with the satisfies the inequality, then there is a unique solution of the problem 2. Here, as applications, the conclusions are supported with some examples, two examples. Example 3.1. Here we considered like this. So all the assumptions of 3.1 are met and thus the problem 2021 has a unique solution. And in example 3.2, we have considered another example. Here, all the assumptions of 3.1 and 3.2 are met and thus problem 22-23 has a unique solution. Whereas in theorem 3.1, we have used example to know, we can see that the restriction of the ellipse is constant or the length of the interval is some. So it cannot be applied to a broader class of problems, and hence theorem 3.2 is sharper than 3.1. On the other hand, the computation part of theorem 3.1 is simple. Thus theorem 3.1 has some advantages when compared to theorem 3.2 and despite its limitations when compared to theorem 3.2. Here the conclusions are: we established the existence of unique solution to fourth order nonlinear differential equations with non-homogeneous three-point boundary conditions by employing Banach and Rush fixed point theorems on matrix. Here are some of the references, and thank you. Yes, ma'am. Yes, ma'am. We are doing higher order also, ma'am. For nth order also we are doing, ma'am. We can apply for higher order also, ma'am. Thank you, ma'am.
Yes, ma'am. Yes, ma'am. Okay, ma'am. Yes, ma'am. My name, I'm Divya Jyoti, research student under the guidance of G. Nanaji Rao in the Department of Mathematics, Andhra University. And my title entitled Congruence Characterizations of Zero Distributive Almost Lattices. And my overview of my presentation is abstract, introduction, preliminaries, certain congruence relations on 0DL, and references. And abstract. Obtain different types of congruence relations on zero distributive almost lattice, called it as 0DL, establishes a 1-1 correspondence between the set of S and the set of all congruence relations on L and a minimal congruence relations induced by a subset of L. And introduction. G. Granger and E.T. Smith examined the properties of lattice congruence and the correspondence between the ideals and congruences. They mainly studied two special type of congruence relations. One is minimal congruence relation induced by a subset of lattice, and the second one is separable congruence relations on a lattice. And my work is the extension of this theory to lattices to my zero DL and zero distributed almost lattices. The concept of almost lattice was introduced by my research guide G. Nanajiro and Heptamu Tirenu Alemu, and studied several properties of amicable sets, ideals, and filters in almost lattices. The concept of pseudo-complemented almost lattices and zero distributed almost lattices were introduced by G. Nanajiro and R. Venkat Arvindraju, and established several properties of these concepts. In this paper, we established several congruence relations on zero ideals and proved that a 1-1 correspondence between the set of all ideals in L and the set of all congruence relations on L, and obtain a minimal congruence relation induced by a subset of L. In preliminaries, in this section, we collect some important definitions and theorems which are frequently used in my work. The first is the definition of a AL with 0. An algebraic of type 2, 2, 0 is called an AL which satisfies the following conditions. Here there is a partial order which is defined as a less than equals to b if and only if a mid b equals to a. Equivalently, a join b equals to b. In AL, this is a partial order, and the definition of discrete AL defined for any xy in L, x join y equals to x and equals to y mid x, then we call it as a discrete AL. The definition of pseudo complementation, let L be an AL, then with 0, then an unary operation A on L is called a pseudo complementation on L if for any A B in L which satisfy the following condition P1, P2, P3, and this lemma is more useful in my work, which is L be an AL with 0 star is a pseudo complementation on L, then A mid B whole double star equals to A double star meet B double star, A mid B whole star equals to B meet A whole star. This is the definition of ideal in AL, which is which satisfy the following two conditions 1, 2, which is if and there exists D such D meet x equals to x and D meet y equals to y. If x in I and A in L, then x meet A in L. In first condition, we are equivalently used as the lemma, which is xy in I implies x join y in I. These are first and two conditions are equivalent. We use it as I required. These are theorems which shows the smallest ideal of L containing S, and this corollary shows principal ideal generated by I. These are some corollaries based on this principal ideal. Are also based on that principal ideals on ideals. Here the definition of annihilator of an subset, which is let L be an AL with 0, then for any non-empty subset of A of L, define A star as a set of X in L such that X meet A equals to 0 for all A in A. Here we denote as A star, and for an element we denote a box A star. These are the properties for the annihilator of a subset, and these are the properties for annihilator for an ideal, and these results also most useful for my work, which is let L be an AL with 0, then for any ideals Ij of L we have the following two conditions, and these are the corollary, and this is these are the of an element X most useful. This is the definition of zero distributive in NIAL. Let L be an AL with 0, then L is said to be zero distributive if for any ABC in L, emit B equals to 0 and emit C equals to 0 implies emit of B join C equals to 0. And yes, ma'am. Okay, madam. Okay, ma'am. Okay, these are theorems and corollaries for zero distributive almost lattices. And here we see some theorem which is generally the distributive is not hold in AL, but we using zero distributive and inhalators, we can use these distributive properties which are most useful in our work. This is the main definition for my work, which is a congruence relation for an AL. Let an L be an AL, then theta is said to be a congruence relation if it is an equivalence relation and satisfying the following substitution property. This is my main work, which is I found some congruence relations on GRDL. First, the congruence relation, which is theta defined as x comma y in theta if and only if x star equals to y star for all xy in L. Then theta is a congruence relation. We know that x triple star equals to y triple star, so we can get the following corollary, and the another relation is x comma y in theta if and only if x double star equals to y double star, which is the proof is follows. And the next congruence relation, we used an ideal I and let L be a zero ideal and I be an ideal of L, and define theta as x comma y in theta if and only if emit x star equals to emit y star. Then A in I, then theta is a congruence relation on L. And this is the proof for above theorem. Here also we get corollary of above theorem, and another theorem is theta is a congruence relation if theta x comma y in theta if and only if emit x double star equals to emit y double star. Here is the proof for the above theorem, and here also we get some corollary of above theorem, which is because emit x double star equals to x mit a double star, and also emit y double star equals to y mit a double star. So the proof of the corollary takes forward. Here is the another congruence relation. Here we are using the join the theta. Okay, ma'am. Here is another. Here we use pseudo complementation on AL and IP and ideal define theta as a x comma y in theta if and only if a star meet x star equals to a star meet y star. Here a star is the pseudo complementation of a, and box of a star meet x is the annihilator of a star meet x. There is a difference in both stars, and here also we get a congruence relation by using this, and this is the proof of above theorem, and the corollary of above theorem as it follows. And here we use another congruence relation, a double star meet x star equals to a double star meet y star. Here is the proof and the corollary. This is the main. Here let B a zero DL and theta be a congruence relation on L. Then the theta class of 0 is an ideal of L. So here we see that. Okay, ma'am. Okay, ma'am. Okay, ma'am. This is the conclusion. Theta here we get it for a theta congruence relation. We get an ideal which is a theta class of 0 ideal, and we are trying to investigate the for any congruence get for any ideal there is a congruent relation. We are working on that. This is my work, and this is the some references. Thank you.
Good evening, madam. Good evening, madam. Good evening, all of the. Good evening, all participants. Myself, P. Mahalakshmi Naidu, lecturer in Math, Government Degree College, K. Perumalapuram. I am a part-time PhD scholar under the guidance of Dr. G. Nanaji Rao. Today, my topic is quasi-complemented zero distributive almost lattices. This is my topic. The concept of quasi-complemented zero distributive almost lattice is introduced and certain properties of QC0DL are derived. Introduction. In 1980, the concept of ADLs are introduced by Swami sir and GC Rao. Next, the concept of almost lattices was introduced by Nanaji Rao and Aptam. The concept of zero distributive almost lattices were introduced by Nanaji Rao and Venkatraju. Now, in this paper, we introduce the concept of quasi-complemented zero distributive almost lattices and derive many important properties of QC0 DALs. We derive some necessary and sufficient condition for zero DAL to become L and characterization of QC0 DALs in terms of prime ideals and annihilator ideals are established in my paper. First, we give these are the all preliminaries. Just a definition of the lattice, definition of the AL, and a definition of the partial ordering in between the two elements. And this is pseudo complementation. This is also used in our paper. This is the definition of the ideal. This is the definition of the ideal, and this lemma is equivalent condition for the ideal definition. This is the principal ideal generated by a set and also the principal ideal generated by an element. Next, this is the theorem. We used the main topic. This is the set of all ideals is again an ideal that is denoted by I of L. And these are filter definition of the filters. This is also very important definition in our paper, prime ideal. For any x comma y belongs to L, x meet y belongs to P, then either x is in P or y is in P. This is the definition of the principal ideal. Next, annihilator definition. A star is equal to x belongs to L, such that x meet A is equal to 0 for all A in A. This A star is called annihilator of A in L. These are the results for annihilator. These are used in our paper. And this is zero distributive lattice. This is also very important topic in my paper. The definition of the zero distributive lattice. A meet B is equal to 0 and A meet C is equal to 0 implies A meet B joint C is equal to 0. This is the definition of zero distributive lattice. These are some results on zero distributive lattice. And also this is some properties of the annihilators. X join y star is equal to x star into section y star and so on. This is mx and hx. These are defined in my topic. The definition of the mx and the definition of the hx defined in the latter my paper. These are the basic properties of mx and hx. Now, quasi-complemented zero distributive almost lattice. The definition is AL L with 0 is called quasi-complemented zero distributive almost lattice. For each x belongs to L, there exists an element y belongs to L such that it satisfies the two properties. X meet y is equal to 0 and x join y is maximum. Here y is called quasi-complement of x. In the topic quasi-complemented zero distributive almost lattices, as simply I say that QC0DAL. This is the example that in in a quasi-complement of an element is not unique. In this example, the 0, 0 has two complements, A B1 and A B2. That means quasi-complement of an element is not unique. I saw the example. And I give the another definition, that is uniquely quasi-complemented 0 DAL. That means if every element in L has unique quasi-complement, then we say that L is uniquely quasi-complemented. In the previous example, the element has two quasi-complements, but in this example, every element has. So here L is called uniquely quasi-complemented 0 DAL. This is also another example for uniquely quasi-complement. Every element has only one quasi-complement. Next, the lattice theory of QC0DLs. In this section, we proved some proofs. First one is every quasi-complemented zero distribute to almost lattice is star zero distribute to almost lattice. And we define notation min L. Min L denote the set of all minimal prime ideals of zero distribute to AL. We may turn min L into Hausdorff topological space by undoing with Hull kernel topology, which has the sets of the form Mx and Hx. These Mx and Hx are also used in the preliminaries. These are as base of the open set. I will define here Mx as the set of all minimal prime ideals P such that X is not in P. And Hx is defined as the set of all minimal prime ideals, the X belongs to P. Also for any subset S of L, Hs can be defined as P belongs to minimal prime ideal such that S is now. We proved some lemmas about this Hx. LB0DAL, then for any X belongs to L, H X star is equal to min L minus Hx. And the next lemma is LB0DAL.
Mahalakshmi Naidkar, can you conclude? Can you conclude?
Conclude. Hx is equal to Hx triple star. This is our main theorem. LB0DAL, then L is quasi-complemented if and only if min L is compact Hausdorff space. This is the necessary and sufficient condition for a 0DAL become a quasi-complemented 0DAL. This is the main theorem in my paper. And also this is another main theorem. L is quasi-complemented 0DAL. Then min L is extremely disconnected if and only if for each J is contained in L, there exists an element Y in L such that J star is equal to the ideal generated by Y star. And every pseudo-complemented AL is quasi-complemented. Using this result, finally we proved this theorem. Let L be 0 DAL, then minimal min of IL is compact Hausdorff and extremely disconnected space. This is the final theorem in our paper. These are bibliography. This is my paper. Thank you, madam. Thank you very much.
Thank you, Naidkar. Are there any doubts from his presentation? Okay. If not, we'll move to the next presenter, N. Hanumant. Is he here? N. Hanumant. Okay. Next presenter, B. Rajshekhar.
Yes, madam. Good evening, madam.
Mahalakshmi Naidkar, can you close your presentation? Can you close your presentation, Mahalakshmi Naidkar? You stop sharing that. Or you leave from the meeting, you try?
Okay, madam.
Because the next presenter has to present his screen. Yeah, Rashika, you can start now, I think.
Yes, ma'am.
But try to complete it quickly.
Yes, ma'am. Good evening, madam. Good evening, one and all. So today I want to demonstrate the model study of 5-dimensional RST bouncing universe in feasibility theory of gravitation. So my name is V. Rajshekhar, under the guidance of Dr. T. Vintla, Department of Applied Mathematics and Andhra University. So the contents of the model are: first of all, introduction, metric and field equations, solution of the field equation, energy conditions, and conclusions, and finally the references. So the current universe is in the phase of rapid expansion, confirmed by the some observational data. In order to describe this accelerated expansion of the universe, an exacting theory of a matter and a dark energy has been proposed in the framework of general relativity theory. The Einstein general relativity theory is the most established theory for explaining the nature of the cosmos. So, it is believed that 96% of the universe consists of dark energy and the dark matter, and sigma is the lambda is the primary dark energy candidate of general relativity. The standard cosmological model, lambda cosmological model, is the most natural model, but it is failed to explain some consequences of cosmos. To overcome this, the unusual issue there is a need to modify the general relativity or develop a new theory which will give a complete description of the universe. So during the study of earlier literature, many authors has proposed some other alternative theories of gravity. Among all these, Sage-Bellster theory is one of the prominent theories which will give a complete description of the universe. In 1986, Sage and Bellster proposed this scalar tensor theory. In this theory, the dimensional scalar function partners with the metric tensor in a simple manner to describe the geometry of space-time. This coupling provides a reasonable description of the weak field, earlier pitch and accelerated expansion drive further. So these are the equations of Sage-Bellster theory equations. Here Rij is the key scalar, phi is the scalar function, so which satisfies this equation too. So to explain the nature of the dark energy, the standard cosmological model is inefficient. To overcome these problems, like fine-tuning and cosmic coincidence, this motivates many others to search some other alternative theories. So the dark energy problem can be studied in a simple way by using holographic dark energy. In recent years, there has been a lot of interest in holographic dark energy models because of the fact that holographic dark energy model emerging model as a candidate for dark energy construction by holographic principle. Thereafter, inspiration from holographic dark energy principle and using the Rayleigh entropy, another holographic dark energy, new holographic dark energy model proposed by Murad, which is popularly known as Rayleigh holographic dark energy model for cosmological research. The RHDE is more stable and dependent on the axis of interaction between cosmos sectors. The energy density of RHDE is given by this equation 3. So here for this model we consider FRW 5-dimensional Kaluza-Klein universe, flat universe is defined by the following metric. It is an isotropic line element. So where AFT is a scale factor. So for the values k minus 1, 0, 1 represents the open, flat and closed universe respectively. So we consider here for this model, flat model, the field equations for the these line elements are pi 7 represents the field equations for this line element. and the energy conservation equation is this one, equation 8. The equation 5 to 7 forms the system of 3 independent equations with 5 unknowns, such as rho DE, rho M, PDE, and the scalar field and the scale factor. With the system, we assume physically viable conditions. Here in this model, we assume bouncing scale factor is given by A of t is equal to e power beta t square, and the Hubble parameter is given by h is equal to a dot by a. So for the above equations 7 and 9, we obtain the scalar field phi as equation 11. So evaluation of Rayleigh holography dark energy universe considering the Hubble horizon as IR cutoff. So for the IR cutoff as a Hubble horizon, we have the rho d energy density is like this, which represents the equation 12. By considering the Hubble horizon, L equal to 1 by h and 8 pi is equal to 1, the above equation reduces to equation 30.
Rashika, can you go to your conclusions? Due to time constraint, can you go to your conclusions directly?
Yes, ma'am. These are the plots of my model, ma'am. Plot of energy density with respect to time. So, dark energy density. For the above plot, see this one. So, these are the conclusions. As the energy density of the dark energy is positive, throughout the evolution of the universe, and energy density for matter throughout the universe is positive, which represents the accelerated expansion of the universe at present and late time. So here we can observe here there is a bounce at the time t is equal to 0. So why? Because we are considering the scale factor. So for the US parameter, this is the graph of the parameter. So before the bounce and after the bounce, as omega tends to infinity, when before the time t is equal to 0 and after time t is equal to 0. So these are the energy conditions. So if you observe here the energy condition, the strong energy blue line indicates the null energy, and strong energy condition and null energy conditions are violated throughout the evolution of parameters, theta equal to 0.5, beta equal to 0.7, and beta equal to 0.9. So which indicates the there is a bounce in the model. So that
Rashika,
the model,
conclusions, please. Conclusions. Go to conclusions, please.
Yes, ma'am. So as the energy density of the dark energy is positive throughout the evolution of the universe, and there will be found a non-singular bounce at the time t is equal to 0. This reveals the universe is expanding at present and late time. From the graph of the energy density and of matter, we observe that it is positive in the entire evolution of the universe, whereas it is a decreasing function in the negative time zone and increasing function in the positive time zone. For the coming to the US parameter, which approaches to infinity at time t is equal to 0 in both scenarios, after the bounce and before the bounce, and it crosses the phantom divide line omega d equal to 1. So the plots of energy conditions reveals that both the null and strong energy conditions are violated in both the negative and the
Okay,
positive
Rashikar.
zones.
Okay, Rashikar. Thanks for your presentation. Because already we are running late. Yeah.
Yes, ma'am.
Thank you. May I call Arvind Rajua, next presenter? Are you there? Next presenter, Arvind Raju. Yeah. Arvind Raj Garu, just wait for 5 minutes. We'll inform you later for your presentation. Just wait.
ఛార్జింగ్ వస్తుంది కదా కాసేపు ఏంటి ఆగిపోయింది
ఒకసారి చెప్పేస్తే ఆన్లైన్లో ఉన్నారు కదా వాళ్ళు, నెట్ కనెక్టెడ్ కదా. Arvind Raj Garu, are you ready with your presentation? Am I audible to you, Arvind Raj Garu? Arvind Raj Garu, if you are ready with your presentation, you can start now. అతని స్క్రీన్ అరవింద్ రాజు గారు.
అరవింద్ రాజు అక్కడి నుంచి కనెక్ట్ అవుతున్నాడండి, ఏదో చిన్న టెక్నికల్ ప్రాబ్లం అనుకుంటాను. స్క్రీన్ అయింది, స్క్రీన్ షేర్ చేస్తాను.
ఇద్దరే అతను ఏంటోనండి స్క్రీన్.
మేడం సార్ సార్ మీరు పీపీటీ ఓపెన్ చేయండి సార్.
మాట్లాడలేదు,
మనది మనకి రావట్లేదు, ఆడియో తీస్తాను. హలో సార్.
బ్యాటరీ
సార్ ఆడిబుల్ సార్, ఆడిబుల్ సార్, మాట్లాడండి. సార్ అరవింద్ రాజు గారు సార్, మీ వాయిస్ రావట్లేదు సార్. ఒకసారి మీటింగ్ సిస్కో ఓపెన్ చేయండి సార్. నా వాయిస్ వినిపిస్తుంది కదా సార్? సిస్కో మామూలుగా మీటింగ్లోకి వెళ్ళండి సార్, మీటింగ్లోకి వెళ్ళండి. హలో, మీటింగ్లో మ్యూట్ పక్కన ఆప్షన్ ఉంది కదా సార్, ఆడియో ఆప్షన్.
మేడం ఇది ఇంకా ఒకటే ఉంది మేడం, ఇంకా లాస్ట్ ప్రెజెంటేషన్
మ్యూట్ పక్కన ఆప్షన్ ఉంది కదా సార్, డౌన్ యారో అదನ್ನ క్లిక్ చేయండి సార్. మ్యూట్ పక్కన ఆప్షన్ ఉంది కదా సార్, చిన్నది యారో, డౌన్ యారో, అది క్లిక్ చేయండి సార్. డిస్టర్బెన్స్ వస్తుంది సార్ మీది. సార్ కెన్ యూ వెయిట్ ఫర్ 5 minutes సార్? క్లోజ్ చేయండి సార్, ఒక్కొక్క ప్రెజెంటేషన్ ఉంది.
షేర్
నాలెడ్జీ సరే చెప్పారు మేడం. నాలెడ్జీ సార్ వేరే స్కాలర్ వచ్చి ఆయన ఆల్రెడీ జాయిన్ ఇంకా క్లోజ్ చేసేస్తాం మరి అతన్ని చేయాలి లేకపోతే ఈయన ఇక్కడే కాబట్టి ఎవరికి ప్రజెంట్ చేస్తారు ఎవరు లేరు. పర్లేదు ఉన్నారండి. ఇతను క్లోజ్ చేసి మనం చేయొచ్చు. మనం మెసేజ్ చేద్దాం. ఎస్ మ్యాథ్స్ వాళ్ళకే తెలుసు మా ఇంటి ఆయన వచ్చిన ఈగో షెడ్యూల్ కాదు. మేబీ అతను చెప్తున్నట్టున్నారండి. మనకి మేడం ఇక్కడ వాయిస్ కానీ లో ఉంది. కెన్ యూ కంక్లూడ్ అని పెట్టేస్తాను. కాబట్టి వేరే వాళ్ళకి ఏమైనా వినిపిస్తుందా? వాసవి ఉన్నారా మీరు మీటింగ్లో? అతను వినిపిస్తుందా? ప్రెజెంటేషన్ అరవింద్ రాజు అన్న ఆయనది వినిపించట్లే కదా? ఓకే ఓకే. మీరు ఒకసారి పెట్టేస్తారా అయితే? Okay, thank you, Arvind Raj Garu. So next presentation is by Sri Hanuman. షేర్ చేయాలండి ఇందులో. ఇతను స్టాప్ చేయలేదు. చేసాను షేర్. ఇదా మీది?
Good evening, madam. Good evening, scholars. So,
మ్యూట్ లేదు కదా?
so I'm going to present the effect of age on COVID-19 patients' outcome by using ROC analysis.
అవ్వట్లేదు కదా? క్లోజ్ చేసేయండి, పర్లేదు. తీసేయండి. అది స్టక్ అయింది. పర్లేదు.
సార్ జస్ట్ ఇట్లా ఉంచుతాను ఈవినింగ్ ఉంచాను కరెక్ట్ చేయడానికి నుంచి పంపిస్తాను రికార్డ్ వచ్చి యూట్యూబ్
from University of California, Santa Barbara. I'd like to thank the organizers and all of you for giving me this opportunity to participate in this celebration of KSR and this. Hello, this is Srinivasa Rao Jamalamadaka from University of California, Santa Barbara. I'd like to thank the organizers and all of you for giving me this opportunity to participate in this celebration of KSR and his contributions. I met Raleigh Srinivasa Rao KSR for the very first time at the 12th ISPS meetings in Bombay in December of 1990. He happened to have joined the stat department at Andhra University 5 years before that as an assistant professor. And he spent considerable time with me during that conference, talking to me and seeking my advice on research and career. And thus, my association with him and the stat department at Andhra University, ever since I kept in touch with him and with other faculty at the stat department in Andhra University. And I make it a point to visit this university whenever I get a chance while I'm in India. Over the past 3 decades, KSR has grown tremendously in stature in every aspect. He has a very large number of publications and produced many PhD students. And several of his PhD students, such as Tirupati Rao, Nirupama Devi, Kuda Nageshwar Rao, Y. Srinivasa Rao. I'm trying to remember some of the names of people that I met. And this is just a short list. Have made a name by themselves, all by themselves. So I happen to have also noticed that KSR makes a tremendous amount of contributions in applied areas and does important consulting work for companies like TCS and the Reddy Labs, etc. All in all, KSR can certainly be considered as among the top statisticians in India today in research, teaching, and professional contributions. I have been fortunate in knowing him closely over all these years. I believe this to be an important opportunity and an occasion and a forum for me to make a couple of comments about statistical growth and statistical research and teaching in India based on my own limited set of observations. These observations go back to the 3 universities in Andhra, with which I am very familiar with. The stat department at Andhra University, which I believe had closer to 10 members at one time, has now shrunk to just 4, including KSR. I am told there is just one permanent faculty member at SV University in Tirupati, in stat department, and none at the AAU, Acharya Nagarjuna University. Stat departments are all shrinking and may in fact be disappearing, with retirees not being replaced. It is an issue that someone like the ISPS should take up and, at whatever level, and with the help of international organizations if needed. This is quite in contrast to what's happening in many universities in the US with respect to statistics. I will describe my own department, my own scene here at the UC Santa Barbara, which I helped start a Department of Statistics and Applied Probability from out of mathematics in 1989 with 5 faculty. In this department, we now have 21 regular faculty, and 16 visiting faculty. And the visiting faculty include people from India oftentimes. We had one the last year from IIT Kanpur, we have one this year from ISI, and so on. We have 80 graduate students, 80 graduate students, and they're all the ones who are doing PhDs and masters. And we have 1,500 undergraduate majors doing BA and BSS, covering areas such as theoretical statistics, data science, actuarial statistics, insurance mathematics, and financial mathematics. I'm not trying to boast, but statistics is a growth area. If one takes a broader vision and with all the gigabits of data around us. My second comment is about the policy of mandatory retirement at age 62 or 65 that seems to be prevalent in academic institutions in India. I think this is a bad policy. While I agree that some should be retired even at the age of 50 if they are not productive in research and making appropriate contributions to related activities. Others, on the other hand, should be continued as long as they perform and meet certain standards in research, teaching, and professional contributions. This is how it is in US and most respectable universities, including ours, where we evaluate permanent faculty every 2 to 3 years with respect to these three aspects, the research, teaching, and professional activities. If one keeps such standards in mind in the main aspects of one's professional life and academic life, this and the stream of continuing contributions that KSR continues to make, someone like him should not be retiring at this time, nor at any time in the near future. My very best wishes for his good health and continuing professional contributions and success all around. Also, my best wishes for the success of this conference and in his honor. Thank you for inviting me again.
Thank you, sir. Now we invite today's function guest of honor, Professor K. Srinivasa Rao Garu, Principal, College of Science and Technology.